All right, I should actually be on mic. Yeah, I'm on mic. How about that? Boy, I don't think my glucose level is going to be kind to me today. I do need to hydrate. I've been sweating a lot today. It was nasty this morning. The humidity is just pervasive. It's awful. You're basically wearing the weather when you go out there. Awful. Terrible. Let's get YouTube started over here. I had a bunch of spicy ramen for lunch. That's why my glucose level's not going to be happy with me. It burns. Everything burns. Every burp, every fart. What I don't understand is that I haven't had anything spicy in a little while, and the second I ate those noodles, I had one bite and then had to poop, and it was a spicy poop. So I don't understand. I don't understand at all. Welcome to Oversharing with Bother. all of my viewers. All right. There's all that. Let's see. I got all my windows shuffled and arranged. I've got Start Soon on. OBS has been running since Tuesday, so all the cameras are still primed. Let's do lights. So lights over here. Oh, yeah, and I popped out YouTube and Twitch, so that should be working. So stand light, boom. Face light, boom. Track light, already on. All right. Then desk light, on. Okay. Yeah, I've got major dark circles under my eyes because I did not sleep because it was so humid. The air conditioning could only do so much to stem the awfulness. I had a fan on me and everything, but it was still miserable. I don't get what it is. Like, when it gets super humid outside, I guess the air conditioner can only do so much. But it really should be removing a lot of water from the air. I don't know why it's not. Nothing is broken. Everything should be working with the air conditioner. Ugh. But yeah, then I got to take the dog on walks, and it's like awful. She knows it too. She'll just turn around and come back inside. Other than that, I'm doing okay. Did my big shopping yesterday, so I won't literally die. I actually don't have much food in the house, and that's purposeful, so I don't binge. Binge eating a little too much. That's why I'm so huge. I need to really start, like, and you know, I'm not gonna, like, you know, drop the axe on a super duper revolutionary, change my life, you know, eating and workout routine. Because when you do that, it's such a shock to the system, you end up not sticking with it. And the biggest thing is to stick with something. I mean, I'm getting up there in the years, and I really need to start prioritizing losing the weight so that all of my internal organs can function properly. And it's very difficult to do because you're sort of set in your ways, right? I'm very set in my ways, and of course, corn sugar is in everything. So I really need to slowly but surely, but swiftly, slowly but swiftly, change all my habits. And I've done it before. I lost all the weight, but that was when I was on testosterone and I could build the muscle alongside of it. And then the testosterone also holistically affects everything else about your life. Like, you feel more awake. I have multiple conditions that cause chronic fatigue, and it sucks. I'm a very tired person all the time. I don't mean to just complain about that, but it's just something that affects my life in a big way. So, yeah, having the hormone was nice, but I'm not going to be able to do that just because of the way my body is. My doctor's not comfortable doing that, so I am going to have to take steps aside from cheating with chemicals. I can't get on that Ozempic. My doctor also does not want to put me on Ozempic. I asked. I'm not above cheating. It's not really cheating. There's a shortcut. Why not take it? I mean, I need to get that front panel printed. I don't know where my filament is. Let me check on that right now. I should be getting another Polymaker gray. Gray is the test print color, but it's also the color of the synthesizer. So, Amazon. Pull that up. It's always dangerous to pull up because you guys will see all the Merkins that I'm ordering. I'm constantly ordering Merkins. They go bad pretty quickly. Just Merkin. It's arriving today. Okay, so I get my filament today. The other thing that I got on Prime Day that I didn't tell you guys about, I actually was able to keep something close to the chest for more than 2 days. I can't do that. I'm too excited. I'm too excited and I can't keep secrets from you guys. It makes me a bad streamer because I don't drop sudden shocking projects on everybody because I'm constantly babbling about the stuff that I'm working on because I love what I do. I love this stuff. Hell, I wouldn't be doing it. I don't have to stream. I didn't have to start up stream today. I wanted to. Check this out. This is going to be the y-axis of the POS CNC. CNC machines are ridiculously easy to make if you have the parts for them. What I did is led with the joke and decided that if I was going to build a tiny little CNC, like a small desktop CNC, I wanted to make sure that there was some kind of a humor factor going into it. The way that a desktop CNC would be most useful to me is if it was extremely accurate and could do very small things. And I found this on Prime Day. This is just an extrusion rail that's done in a U shape, and then they have an Acme drive on it. So this is perfect for the X-axis, or for the Z-axis, for lifting and lowering a router. Then, because Burn the Subs kind of took a turn in the directions that it was going, I don't need these motors. These are powerful three-phase motors. I don't even think this project needs to be that strong. I guess if I want to do fast CNC, they're going to be absolutely vital because these are servo motors that will be controlled by the Granite Devices universal motor controller system. So what I'm going to do is have thick belts, very powerful motors, and a janky CNC frame that is going to have all of the controls in a cache drawer that I have to lockpick to get into. It's very easy to lockpick. So this will be a small pulley, and then this will be a very large one, so that this motor is going to have to work pretty hard in order to move this thing. These size motors, by the way, I could take these motors today and I could attach them to a skateboard, and I could use 1 or 2 of them to propel myself. Well, I don't know about my current weight. Maybe I'd have to lose a little bit of weight in order for that to happen. But still, these can propel a man. So, and they're not super wide. I could really use torquey motors instead of these. We bought these because Burn the Subs was going to use them, and I never got around to implementing them in Burn the Subs. But they will be absolutely nuts if I use them on the CNC, and I have enough to do that. So we're going to have a kind of a special CNC. This thing's going to be controlled by a weird controller, and it's going to be super powerful. So that'll be really neat I can't wait to see these things actually piloting axes around and how fast they might be. I might even have to bolt it to a table. It might be that fast to the swing of momentum of moving that router around. Probably run it super hobbled and slow. But I mean, one thing that I would love to be able to do with it is create 1/24th scale RC car parts out of the thing. It's not like economically I might as well have just bought more of the car parts because they're not expensive, but it would be fun to be able to create my own. Plus, CNC capability is just something that I've been lacking for a long time. So with CNC capability, I don't know exactly what we do with it, but we sure as hell will put it to work. I can't wait because this will be a really nice. Except for the fact that I'm using just a DeWalt router on the thing, I won't be able to control spindle speed yet. And I think the Granite Devices controllers can move a 3-phase spindle motor, so I don't need to get a big 3-phase spindle motor kit. I could just buy the motor. Then of course we need to do water cooling on the motor, which sounds fun. Wonder if I could water cool the motors. I don't know. You can only really cool this plate, so I would need to make this out of metal. I guess that would be a job for the CNC, is making aluminum these pieces and then finding a place where you could put pretty much just 2 tubes, maybe bolster out the end cap and just have water go down, over, and out, and that's it. You wouldn't need a lot of contact. Water, of course, holds quite a bit of energy in it. And as long as that plate was the temperature of all of your water-cooled stuff, that's fine. And that would cool this plate on the motor, and then the coils, I guess, would get the benefit of that cooling. You can't really get into this setup. It's a shame you can't, but you can't. Most of this is just metal in service of moving a thing. I wonder if you could take... Oh, copper would be pretty dangerous to run, huh? If you did a thin copper tube and just came up and around the coil, the outside of the coils. I don't think so. I don't think so. It's the not the outrunner. It's the ones with the where the blah, 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 blah. One of the spindle motors, the three-phase spindle motors are the ones that you can water cool better because you can put a jacket around the outside. This you can't put a jacket around the outside because this is the part that moves. Out here where all the torque is. Cool stuff, though. I can't wait to get this thing semi-running. I ordered this pulley, too. I don't know if that gets here today or not. And then this is 10-millimeter belt. I need to find a loop belt that's the right length. I don't know what length that's going to be, so I'll have to measure it when it gets in and then order it. That's why this is so slow. I wish I could have just a pile of parts ready to go for this project. This project might be a one-stream project if I get all this stuff together. So that's what I'm working on right now. I've got a couple different systems that I need to kind of decide how they're going to come together in order to make the POS CNC. And then from there, we could maybe do a build day, and I could try to figure out how to get, like, how am I going to control, how am I going to get the data to Granite devices? What's going to control that? Would it be a Raspberry Pi? Is there an RPi CNC? Or is it a Linux computer, in which case I would love to use my, what do you call it? Use my brain for once. That little Windows, that industrial Windows PC. I mean, there's also the fact that, like, why am I doing this? I have a milling machine. I could adapt these motors to the milling machine and possibly achieve my goals as well. And then there's something to be said for having a manual milling machine, but CNCing this thing would be kind of interesting. I wonder. These might not be strong enough, though. If you look at all the CNC milling machine kits, you've got much larger stepper motors on the mill. And they changed the gearing out, too. So it's possible that these would not be strong enough, even though these are pretty strong motors. I don't know what the torque spec is on these. I don't know if there is a torque spec. What does it even say? These are the SK3 AeroDrive 5055 280. I don't know what that means. Made in China. In it, bruv. There's a lot of open airspace on this. Huh. You could definitely fit some cooling in this piece right here. I don't know. But yeah, this is something that I'm excited about. I'm getting this thing running. This motor is kind of rough. There's a big cogging. There's a lot of cogging that happens with it. Of course, if you do this, you can brake the motor. BRAKE. Whoa! It's hard to move. Only one phase. Oh, it does a lot less. Oh wow. Okay, actually, that's pretty effective. Holy shit! That's actually more effective than holding the three together. No, it's not. No, it's not. That's a good workout, though. Okay, put this aside. We got our work cut out for us today. I want to do a little bit more programming with the audio stuff and come up with a schema that will allow us to flip the waveform type. And maybe we'll put the AB encoder into that. Flip the waveform type and change the frequency. Those are two things that I would like to do. It'll have to be one of those obnoxious click-in menus where you select the thing, click the knob down, then you select the other thing, click the knob down, and then it backs you out of the menu. That'll be something we implement with the screen, but initially I would like to have it as like a callable thing, like a function that we can mess with, because this is going to be a big program and it's going to do a lot of stuff. So we need to kind of split the functionalities out. There needs to be like the main boot up program, and then there need to be functions aside that. And then I don't know where we go from there. There's a lot of stuff. There's a lot to do. But we're doing it in little bitty baby steps, right? So we'll do a little bit of software today because that went really, really well last time. The software stuff went really well. So we'll do a little software today, a little software and hardware. And oh, let me boot up the scope. It takes forever to boot. This scope takes so long to boot. It's the only disadvantage to this scope. Everything else about it is amazing. But since it's an Android base I've already hit the power button, by the way. This thing is on its way. Here we go. It gets faster. Every time you boot it, it gets a little bit faster at booting, but it still takes a solid minute after so many weeks of using this thing. The other thing that I have to consider with the CNC machine is currently this thing uses rollers. It's got Delrin roller wheels. We found on the 3D printer that the Delrin rollers were not that great. If they're all tensioned properly and everything is set up perfectly, the Delrin rollers do really well and they're pretty accurate. But linear bearings were much better. I have a bunch of linear bearing stuff from, again, the burn the subs things that didn't come to fruition. I have enough linear bearings to do one of the axes in linear bearings. So I figure the x-axis or the I think that's y. The y-axis will be linear bearings. This thing will have Delrin rollers on the back of it with a plate or something. Or I could do Delrin rollers on y and then linear bearings on this thing. But I think that would require 2 rails of linear bearings. And then I'd have 4 linear bearings that would hold this thing in place. I would love to have done linear bearings for the whole thing, but whatever. Roller bearings are nice. But the Delrin rollers, like, I don't know if they'll, because remember, one of the things that I'm doing with this, and I know I explained it earlier, but people are just getting into chat. There were like 4 people when I explained it last time. I'm looking at the numbers. We've got some viewers now. But when I have the big wheel here and the small wheel here, this thing will be able to move very, very accurately indeed. I'll be able to move it in very small increments, because however small the increments are on a servo motor will get multiplied, right? The fact that I'm using Delrin rollers might undo that accuracy. I'm not sure. I'm not really sure. The motors will know where they are because they know where they're not. No, the motors will know where they are because they've got a really nice encoder on them. That'll be interesting to see come to fruition. It'll be really cool. See this thing in action. I can't wait. I got all the parts over here. This is another 1999 tracker music, 90s tracker music playlist. Turnigy, Aero Drive. Yeah, this is the POS CNC project. This is a cash drawer, and I can't get into it. I can't get into the cash drawer. It has a lock right here that is incredibly easy to pick, though. Got access to SHA hash cryptographic hardware accelerator in your ESP, your Xiao ESP32C3. What the heck? With Rust. Oh my God. That is a lot of jargon, but it sounds exciting. So you're able to do cryptographic stuff with that. That's weird. Microcontrollers are getting crazy these days. I had to order a couple more rails, and it was like a $30 order. Only $30 though. Open Builds. If you're in America, Open Builds is kind of amazing. Open Builds is an amazing website. Everything they have is like, it's like you're like, oh, I need a 500mm rail. Oh man, I gotta go order that and then have it shipped. No, it's like $10 and $20 shipping. So I ordered a bunch of rails. I ran out of rails because I used the rails, the 2020 rails, to build the Burn the Subs board holder. I have a big stand that holds up the 2 old Burn the Subs boards that I had on the wall. So by all means, I should be building this thing out of 2020 hardware, and we were about to do that and use those servo motors for it. But I decided to go back to stepper motors and keep it sort of relatively the same hardware so that I could build a more long-lasting board that had sort of a more interesting target, and then put my effort into robotics after that. So we're still getting to after that. We're still working on this board. I want to do this module tester module so that I can fix Dave's module and get it the heck out of here. We've run into a lot of problems with doing that. These analog basically entire synthesizer modules are a lot to deal with, and I've been dealing with the M303 side of things, reverse engineering it, when I ran into a problem, and that's that I don't have any way to test modules without getting out a lot of stuff. and I don't know if the stuff that I have is the right stuff to test modules. So we're building a module tester module. It's just another episode in the yak shaving contest. The 303, I will work on reverse engineering a little bit more. I need to set up maybe on my other desk where I could do some of that hardcore reverse engineering. You guys have seen it in action for far too long. I've had too many streams of that. So, we need to keep the variety going here. I usually work on a couple different projects at once, and then some of them fall by the wayside and some of them get finished. I have a track record of clearing projects up until 2 years ago when everything seemed to stagnate all at once. The modular synthesizer project, I haven't finished it because it's a permanent project, but I've finished modules of it. But if I had the module tester module, I could tune some of these VCOs a little bit more easily. We can do some of the analog troubleshooting that we need to do, things like that. My modular synthesizer is not done to the point where I can fully utilize a VCO, which is a weird place to be. But yeah, anyway, efforts continue. Again, like one of the things that I really want to work on, and by the way, this is trauma. We're exploring trauma right now because I've been berated by chat for not completing things. And that's what happens when you work on stuff. You don't complete a lot of stuff. You sort of work on the cool parts, and then the really boring parts stagnate. And I try to keep away from doing that, but everybody's subject to that sort of thing. But the other stuff that we have, like the resin 3D printer, I would like to at some point get a model of the Satsuma from My Summer Car and edit the inside away so that it is an RC car body, but then I want to have stuff like the quarter panels fall off. So use magnets to kind of hold it together, and then put it on the 1/24th scale RC car so I can race that thing around, and when it hits something, it'll blow up like a Nokia phone, or like, the car in My Summer Car. And then I can have a newspaper fly up in the screen. But that's something that I haven't even been able to give any thought to, because the module tester module is at the tip of the yak and it needs to be shaved. It is an entire, this is like an entire ecosystem that I now need to build. This project is making a test device from nothing. And while we're getting ideas from Mutable Instruments, I'm not using her code. So we've got to make this from the bottom up. And in order to give this thing a blistering amount of functionality, we need to implement this screen. The screen is a dot screen. It's got dots instead of characters. And so what this will be able to do is actually display waveforms and stuff. That's going to be its own big thing. I would like to split it up into quadrants, though, and have you able to select what each port does. In terms of outputs, though, we only have 2 channels of output. I could get more, but I don't think we need more. So I'd have 2 channels of output, one set for 2 volts and the other set for 10 volts. So it could be a CV and a waveform output. And you'd be able to select the waveform and maybe select how the CV is sent, including controlling it with the knob. We'll have to figure that out. What is this music? What is going on here? This is tracker music from the 90s, but it's gone in a direction. Song name, fieldday.mod. What the heck? I think we're skipping this one. Scorpic, Field Day. No. go to Cosmic Compressor. This is what we're listening to right now, in case you're curious. It's just weird beep boop computer music. How'd everybody's day go? How's your Wednesdays? I actually got a little bit done on this on Wednesday. I configured the input channels. Now, I can have every single of the 6 outputs go into these op-amp circuits, and then that can serve to auto-tune everything. Well, I could have it reference the -10 and then send the -10 through here, and then have this sort of configure its ranges based on that. But I'm thinking that every single one of the plugs should have the ability to like sense what the current is coming in. What's up, Taters Games? Good beep boops. Yes, they are good beep boop computer music songs. I don't know. We'll see how long the stream goes. I mean, we can play around with some of the stuff and figure out if we can sense like the current, not the current, sense the what was I saying? Sense the frequency of the incoming waveforms and stuff. If we can get good frequency sensing on this thing that's well tuned, then I can use it to tune VCOs. I'm excited about getting that functionality out of it too. So we'll play around in the microcontroller space today, now that I've got all the hardware set up. Like this circuit right here, I have a potentiometer on it, and I'll probably end up putting a lot of these instrumentation potentiometers into these circuits, just so that I can come back and say, wait a minute, is this thing in tune? You put it into a mode, have it sense the thing, and hook it up to the oscope, and then tune it very carefully. That would be the kind of thing that I could do to keep this sort of as a piece of instrumentation. But yeah, we'll have to play around with some stuff and see if we can get accurate frequency sensing. And then I guess what I can do is I can program in CV voltages that correspond to different notes, and that way I can take it through a whole range of values in order to tune things like a VCO. That'll be really cool. I don't know about sequencing and stuff like that. I guess maybe it should probably sequence a little bit, but I don't know how I want to control that. That's something to figure out. You just have to do random sampling, but it means we get to work on these tools a little bit, and I'm liking how they come together. I think this is a little weird and clunky, the patch cable system. It's not that clunky, it's just a little weird. And then having patch cords connect the different elements, and then you call on the elements in your code. It's pretty neat. It's actually a pretty neat way to do it. It takes a lot of the craziness away from doing like a VCO. If you guys saw the way the other VCO went together, the one that the Hajiwo VCO went together, it functioned by making these enormous wavetables, and it does it almost every cycle. Because if you move any of the knobs, it needs to make an entire new wavetable that it follows. It's got to be harsh on the microcontroller to be creating that much data. It's like a big table that represents all of the PWM values that represent the different voltage values that the Salin key filter puts out. And so every cycle of the microcontroller, it's making these tables. The thing runs at 133 megahertz, so it's like screaming along at unfathomable speed. Like the Arduinos that we use were typically used to 8 megahertz, and this thing's 133. It's unfathomably fast. If you had any sense of how fast an Arduino is, which you don't, then you have absolutely no sense of how fast the RP2040 is. Like, I mean, even when you get down like 8 megahertz, right? In a regular Arduino, that's doing things so quickly, you cannot fathom. And what I mean by fathom is, you know, I know about as long as a second is. Maybe a little bit longer than that. Like that maybe is 1 second. I can fathom that. A millisecond is a thousandth of that. One 1,000th. It's unfathomable. And at millisecond timing, you can still barely fathom how quick a clock cycle is in any given microcontroller. In an 8 megahertz, it's a little bit closer, but you know, we're talking about milliseconds and microseconds. It's incredible. And then you multiply that, 133 megahertz. How fast is a cycle then? Are we talking picoseconds, nanoseconds? We're down to nanos. It's incredible. It's an incredible, unfathomable thing. Oh yeah, AutoCAD sent me something about renewing my license. I wonder if I close this and open it up again, if I won't be able to use it. I think I'm going to do the MIDI port on the back of the device because it's already a little bit cluttered on this front panel, and I want to keep it kind of simple. We have 6 IOs, 2 audio outs. One will be for CV, and the other one will be for audio. And then we have 4 in or outs. And I wonder, well, it would be CV and gate, out or in. So they would have to have like an LM3904 on them, which would be where's MS Paint? MS Paint. If they're all going to be I/O, it would need to have an input and an output gate, which is 2 pins of the micro, or port expander. I'm not sure which one I want to do. Autodesk is nearly as evil as Adobe in that respect. I recall that the last times that I had to do this, it was just literally selecting an item on a pull-down menu. Like, it was like, hey, is this still right? And you're like, yeah. I was like, oh, okay. And then they renew your stuff. So I hope it's like that still, because, you know, they could easily implement something a little bit more complicated, and then I'd be in trouble. I shouldn't talk about... I talk about it openly. I am inviting them to do so, but they never do. But that could all go wrong. Like, if I dedicate transistors for I and O on that, but then I also have an input that goes through an op amp, instead of this... Wait, no, that would have to sit... This would sit on the circuit. But then that means that VCC would be on there with a 3.3K to ground and a 4.7K to positive. This would need to be reauthored a little bit. I think it needs to be changed a little bit. This is an input, so this is a gate sensing input, and so this we don't need. And we have 6 analog inputs, right? Oh my God, this song is hard. This shit goes hard. Yeah, we have 11. Yeah. We've got plenty of analog inputs to sense voltage levels at. Although 2 of them are taken by this, so 8. We have 8 of them to go. So we can select a bunch of these to do, it would be, yeah, 0 through 5. And then we would have to add this circuit. This is a very good circuit here, by the way. This circuit set to plus minus 10 volt, which means that this value changes. And actually, I have that value. I set it up the other day. Yesterday. The other day being yesterday. We can measure this. Let me get the music out of here. We'll just start. We'll just start. You guys can... I hope you guys can tell that I'm so excited about this that I'm just working at it. Even when I'm relaxing, I'm thinking about this circuit. This is a good project. This is a microcontrollery project that allows me to further my analog skills by having something that's capable of actually operating with these modular synthesizers. Hi, my name is O'Bother, and I have been addicted to working on analog. So I've been addicted to pain, both mental exhaustion, pain, and soldering iron fumes. Welcome to... Oh, wait, no, I just closed it. I just closed my dashboard. Welcome to my Twitch channel. Things have been going a little bit rocky this summer. I have had quite a few projects that haven't really been progressing. We did one very successful thing, which was buy a broken 3D printer. It was a resin printer. I got it running pretty easily just by cleaning everything. There wasn't really all that much complexity to it. I'm also addicted to hacking things together. Yeah, a lot of the thing is, like, I always start a project thinking I already have everything that I need in order to build this thing. I've seen kind of a drive towards just buying parts and not doing anything with them in my Discord, and I urge those of you that are buying parts to get to the point where you start actually building something, because that's where all the fun is. I have been trying not to order stuff, and I just got done ordering stuff, a bunch of stuff for the CNC project. It happens. But we've started a lot of things and not finished a lot of things. I had the one 3D printer project that actually did finish. I'm going to be putting that to use with other projects. In that same vein, I've been trying to fix my buddy Dave's M303, his modular synthesizer. That also spawns off of our project to build modular synthesizer stuff, because this stuff takes all kinds of different forms. Modular synthesizers, first off, don't have to be expensive. It takes some expense to get to the point where they're cheap, Once you get there, they are cheap if you DIY everything. But DIYing everything, even for a skilled engineer as myself, I'm an actual engineer with a degree from a university, and I've received paychecks from the FBI for doing engineering work. We don't do like a PhD. Well, we do PhDs here, obviously, but we don't do like in order to be called engineer, you don't need to take a specific test. But if you receive a paycheck for being an engineer, you're an engineer. That's as far as it goes. So I'm an engineer, certified. And I'll tell you something, these analog circuits, they suck. They're so difficult. Luckily, everything about them is known. A lot of people aren't sort of going off into space with these modular synthesizer modules. We are building a Eurorack system, which means that everything takes positive and negative 12 volts. That's in the power supply. That makes things a lot easier because you don't need to do a virtual ground in order to make your positive negative swings. All this stuff exists on a number line. So you've got your zero, you've got your negative, and you've got your positive, and everything exists within that. And then sometimes you DCI stuff and make it outputable. But all of your signals on all of your plugs on the modular synthesizer, it uses these headphone plugs. I don't have an end-to-end one sitting here, but I do have this. Like, they use mono headphone plugs, right, on the Eurorack module. Mainly because if these were all 1/4 inch, it would be huge. There'd be a huge amount of cables. It'd be very unwieldy. You're basically putting together patch cables in order to functionally create out of modules your own synthesizer layout. All of the plugs, all of the stereo or all of the mono plugs that you put into this thing they can't like blow up your system, right? They will only exist within a safe voltage, and the safe voltage is plus minus 10 volts. Some things cook it and they go to 12, but everything should be able to tolerate 12 volts, positive and negative. So it's a 24 volt system. The full potential you're getting there is 24 volt, peak to peak. So 24 volts peak to peak, you plug it in anywhere, it will not blow up your system. That's the guarantee. That means that dumb musicians can plug stuff into their nose if they feel like it, and they're not going to blow up. With our modular synthesizer, everything I'm doing is DIY. It makes a lot of stuff difficult. A lot of stuff doesn't work. Nothing is tuned. So I've been working. After yesterday's stream, I now need a Teensy. Yes, you do. I have an electronic sax idea I want to build now. I have an automaton too. It's sitting around here somewhere. I don't know where the automaton is. I think it's up there. No, it's not up there anymore. Oh wait, maybe it's behind that speaker. Yeah, I can almost see it. I'm gonna fall over. Okay, I'm back. So our power supply is positive, negative 12 volts. Now in some Eurorack systems, you can have 5 volts, and you can have some other pins that do stuff. It's like, but generally, like 99% of your modules are gonna use plus minus 12 volts. So doing that, discovering that, reverse engineering Dave's 303, I've run into some problems here, and that's that I don't quite have enough stuff in order to operate like any given piece of hardware and test it. And in order to test it, I've been taking out a lot of things and I got to tune this to there, and I need a voltage supply here. I need a second or third voltage supply coming over here. It's not really working all that well. So what I'd like to do, what I have wanted to do for some time, is build a module that can test modules. Now, stuff like that exists, but when you buy something like that off the shelf, you're going to be paying hundreds of dollars. So what I've decided to do, what's up, Suzal W stream? What does that even mean? What does that mean? That's like the Zoomers that use weird emotes, right? So yeah. We need a module that can test any given module, and I need to be able to make all of the complicated signals that it takes in order to test these things. Now, I can use it alongside the oscilloscope. That's a tool that I'm always going to have. And what we decided to do is make a frame for it. So I now have a frame where I can put a module testing module. We just need to make the module itself. Now, in order to test external devices, we're getting inspiration from Mutable Instruments. Mutable Instruments makes all kinds of cool stuff. They've gotten out of the game. They're sick of it. They're sick of the people. They hate everyone. They hate everything. They're hiding under a rock. That's essentially how you have to treat all this stuff. When you DIY Eurorack systems, all of the creators of these modules are not to be contacted in any way, shape, or form. They may have a website that'll help you out. Other people may have websites that'll help you out. You can literally buy the circuit boards and you're just off. They just throw you off the dock and you're just on your own. And it's great. I love it. I love the challenge of that because I've learned a whole lot about DIYing modular synthesizers. So anyway, as I was working on Dave's M303, I ran into some problems with the schematic, and I discovered that, you know what? In spite of all this stuff that I'm doing, I don't really have a way to test like the gate functionality of this. I don't have a way to like test all this stuff in one like sort of neat package, and my desk was becoming more and more frayed. That kind of harms my ability to work on a multitude of different projects at once. So what I'd like to do is create a module tester module, give it one of the nicest screens that I have in the shop, which is a VFD, which will give it a particular look. It'll look actually really cool. And then give it the functionality to output and input all the stuff that I would need in order to test Eurorack modules. So we started off with a PicoPi, and we tried to get code that would run an output, that would run a DAC, a digital to analog converter. This DAC that I bought was about 14 bucks. It uses I2S. It's called the PCM 5100, and it kind of rules. It kind of rules. I don't know how it's doing this. It only has 3 volts going into it, and yet the output is positive and negative 6 volts. I got a peak-to-peak value of positive negative 3 volts. I got a peak-to-peak value of 6 volts across this thing on its output. It has 2 outputs though. I could potentially, it's possible that I could put another one in here, and then I would have 4 channels of I/O. That would enable me to do audio and then multiple CV. That might be something I want to consider, and that's why I kind of want to make this a little bit modular. I'm not sure if I want to use 2 of these things. Do I have 2 of these things? That's another consideration. Hold on, let me put this away. This is a filter that I would like to test using that thing. Actually, we know that filter works. Julian tried it, but there's still stuff about this filter I don't know about. So yeah, what I'm trying to say is the yak shaving will continue until Bother is satisfied. One thing that I need to get back to is burn the subs, but before that, we have an absolute mountain of a project ahead of us. The module tester module is taking the full bore of my efforts from now. I've created the op-amp circuit that will output a CV and an audio signal. The question is, do I make them all output CVs so that I have all of the outputs completely configurable? Miguel Oz, subbing for 52 months. Miguel Oz, thank you. Thank you, thank you. Thank you for helping me fund whatever the hell I'm doing today. I don't think I have a MIDI output to test with this MIDI thing. Well, we'll put the MIDI plug over here. I made a breadboardable MIDI plug just for, you know, like audio and whatever other purposes, because you always end up messing with MIDI when you mess with microcontrollers. I mean, Teensy 3.6 would have all the I/O that I would ever need, but I don't know if I can bring myself to use this for this project. The Teensy 4 is a beast, actually. We should stick with the Teensy 4, because if we're doing characterization of incoming signals, this thing will have the highest resolution because it's got all that speed. So the question is, do I have another one of these, whatever it is, the output modules? I don't know if I bought the pack of 3 or if I just bought 1. They come in packs, though. You can buy for like 10 bucks. You can buy a bunch of these things, and perhaps that's what I should do right now. Yeah, let's buy more of these, because if we do 4 channels, I think that'll be a good amount of channels. I was just thinking, because just now I was just thinking, like, what if I want an LFO and a note, a 1 volt per octave, and an LFO, and I want audio going into a filter from something else. So I think I do need to have 4 channels. I think I need to add another device to this. I wanted to look at what this thing is too, because I think this is a DAC. Sorry, an ADC. But I don't need an ADC, because we have like 11 channels of analog input here. So what I can do is I can put a voltage sense on all of the outputs and inputs. Every single one will get the op-amp circuit, and that way, if I want to, I can output a wave onto a channel and then sense it back and tune. Celia Russo, 81 months, with some kind of an Imgur link that is completely unvetted and a giant willow emote. That doesn't show up as a giant emote on the thing. I see a cat's butt. Willow does not sploot anymore. She doesn't do this. She doesn't do this anymore. I don't know why. It's so wrong. I feel robbed. I feel robbed. The PCM 5100 will be our IO. That thing puts out a plus minus 3 volt signal, which is insane. So I've had to take that signal. I said plus minus 6 volts. Actually, let's take a look at that signal before I totally ruin all my notes. Oh yeah, and I need to measure this. Well, anyway, so here's the deal. Here are the outputs. They're going to go through amplifiers that will buffer them, and I guess I'll take them all to plus minus the higher voltage, plus minus 5 volts. So this circuit here, this circuit will be on every input or output. Every IO. That way we can sense back everything that we input or output. I've got it too cold indoors if they don't melt. Well, that's a good thing. Willow's got her skin condition thing flaring up, so it's good that she has a cool environment at least. So our schematic is starting to come together. It's starting to take on a form. I think I need to redraw it somewhere, but what it's basically going to be is... Oh, wait, that's the wrong direction. Nope, that's wrong. That's wrong. We will take in... So I don't need this one. By the way, the magic number is 62.4. That's how I scale this stuff on the I/O in order to be the proper voltage level. But these will be on every circuit. Every plug. And this will be A0 through A5. So A0 through A5 will get every plug in it with this circuit that compares it to -10. What this does is if you have a positive or negative signal, you have a bias here of 2 to 1 for the mixing. You have a plus or minus 10 volt signal get applied to a -10 voltage reference. And what that does is it flips your voltage reference down to the negative part of the number line so that at whatever it is, at positive voltage or whatever, it doesn't cross the number line, it's in the negatives. It then gets inverted by an inverting amplifier that actually damps it down to 3 volts, 0 to 3 volts. And since the MCP 6004 is only being supplied 0 to 3.3 volts, you can't blow up your microcontroller. It protects your microcontroller. I mean to be able to connect to I2S. Yeah, it's pretty cool. Got some of those. I want to do a modular synth a couple of years ago. It's super duper easy. It's super duper easy. The code is very organized, and you use the Teensy audio tools to put it together like it's a Node-RED flow, and then cut and paste it into your code. And then below that, you can then put together your controls for all your stuff. So it's done in a manner that's very accessible and easy to use. I bought a cheap 7-inch screen panel from a local seller. They effing put a shipping label sticker onto the screen and shipped it. Is it a glass front screen or is it plastic? That's tough. How do you do that? You need like very careful scraping. Taters Games with a Prime for 3 months. Taters Games, thank you for subscribing. That is very nice of you. You guys got a hype train going on. Sub, gift, or use bits to get on the next level. What level are we on, guys? Man, when Burn the Subs was running, we were able to do some pretty beefy hype trains. We did some pretty beefy hype trains. Now, are we only plus and minus 5 volts? Because trigger signals go to 8. So I would like to be able to sense what the gate level is. Because if we get a gate signal coming in, I want to make sure that it is able to actually affect, you know, a gate signal is able to actually be made out of the thing, right? So that might mean a little bit of calculation into 100K through a 3904 and when that actually pops off. But if we have voltage sensing on every channel, and then we have 4 CV capable outputs, that means that, let's X4 that, 4 CV capable outputs and voltage sensing on every channel. That means we'll have 4 configurable I/O and then 2 configurable inputs that can be either gate or clock, basically. The clock or gate coming in, or just an O-scope channel, an O-scope style channel. That'll keep things kind of generic. It'll keep things like configurable. We can have a CV input, or like a like a CV input going into one of the ins that has the audio stuff, the audio output on it. It wouldn't matter. It's okay that that's sitting there. On-screen celebration. Did that do anything? Did that do anything? I can't see it if it did. It probably did something on Twitch. I don't see this. This is disruptive and should be disabled. I should probably disable this. Heat gun and patience, yeah. That's about all you can do. It's glass? Okay, so you got it off. Man, that is just completely irresponsible. I don't think we need LED indicators, and we're just doing this AREF here of negative 10 volts. That does the number line shift. It's funny though, minus 10 would be used for a plus minus 5 volt input, because you're shifting it down. You're shifting the whole number line. So plus minus 5 volts is 10 volt peak to peak. You're taking that peak to peak and you're shifting it down negative 10 volts, and then you're flipping it and scaling it down to 3 volts with the op amp. So I don't think it is plus and minus 10. We won't have the ability to measure things that come in that hot. But gate voltage is 8 volts. So if we use this to sense gate, we're not going to know if the gates are hot. But I can scale, the thing is, I can scale it to 10 volts with the resistor, but it's still, is that even accurate? I can have it sense, I can have it do like a 12 volt wave. Did I actually have it doing that? I didn't. I had it doing a 6 volt wave, didn't I? Oh, but I added a 12 volt source. Like here, let's just do it. Let's just do this. Figure out what I'm missing here. Is that LED? No, that's just a reflection off of the gold. So what I've got here is an input circuit that's referencing the negative 10 volt source here. I have it running to here where I jumper it over to the output from our op amps here. One of these, because this is stereo, and I made them both output a sine wave at maximum amplitude. So you've got a sine wave at maximum amplitude. Waveform sine, amplitude is 1. Frequency is the C note, 261.63. That's pretty accurate. That A to D is pretty accurate. Oh yeah, I need to actually, I can't disable it. I can only make it worth 1 billion bits. Oh boy. I used Tomato's Prestige. He made a Prestige. It was, what was it, like a million bits? And I had 1 million bits. And I used it, and he ignored it. I think he fucking hates me. I think that man hates me. I know he doesn't approve of me being in his chat, but he can't do anything. Okay, let's see here. So I need to order more PCM 5100s. So on Amazon, if you're in America, these are very easy to get. Is it PCM 5102? And you could buy a pack of 3 for $12. Like, this is the easiest part about the whole project, is using I2S with the Teensy 4 is so easy. So in order to have 4 channels, I guess I'm going to end up buying 3 more of these things. So let me just buy it now. Costs less than lunch. And I get them tomorrow. Oh my God, Jesus Christ, that's a little crazy. I could have done same day and gotten it today, but I don't think that's worth. It's not worth the human misery that the Rube Goldberg machine of human misery that I activate by using Prime. 1 million of those bits you pay for, not the free ones. Yeah, that's. Oh yeah, not bits. I meant channel points. When I said prestige and channel points, I meant channel points. If I gave him 1,000,000 bits, he would be pretty excited about that. I2S works over SPI. No. What? No. What? Huh? No, it's I2S. It's its own addressing thing. It's you send. I mean, you need. I think you need 2 separate channels if you're going to do 4 channels out of this thing, because you get left-right with I2S. I don't think you do a chip select on it, so you just do 2 channels outputting from the thing. The Teensy 4 is fast enough, I think, that we're able to use multiple of the I2S lines, but then I2S2 is going to be used for a second one of these things. I2S is unfortunately a very what is it? It's you need to have it dedicated. It's you know, it uses a dedicated line. $600 megahertz? Is that what this thing runs? The Zhao is 133. It's unfathomable, these speeds. So we're gonna have 4 of these. Let's how should I do this? I should probably nuke the stuff that I'm not using. Like this gate input, we're not gonna do. No gate input. I'm not doing this complicated power supply thing. I don't know why this would be done like this. Where it like mixes the two. I don't understand that. So our AREF is, we've got 2 AREFs on the field. One uses a 3.3K and the other one uses a 300 ohm. I don't know which one. We'll use whatever one I have on that little board. So we'll just keep this here. AREF we're not going to do. I have a feeling that the analog reference is going to be good enough. What's up, Madam You? How you doing? Man, you YouTube viewers really stick with your YouTube, don't you? You guys are spoiled rotten with your good player and everything, and your not craziness. So 2 of our inputs are going to be this. Let's get that over to, well, I want it like an input section. So let me get this away. We're not going to do, the LEDs are going to be driven by the microcontroller. I don't know what they're going to do yet, but we're going to make sure that they do something useful. So 1, 2. Oh, those are the outputs. I actually wanted the input one. Control Z. Oh man, all my deleting? Yep. Because this is all I want is this gate in, and I'll have to. I flagged the wrong piece for deletion. Let's just put this over here, and we'll get rid of all this stuff that we're not using over here. I do have some of those 2.5 volt analog references, but I think the Teensy's internal voltage reference is probably enough for it. I don't think it needs anything else. And gate out will just handle from the micro. It'll be able to. Actually, wait a minute. How are we handling gate out? Oh yeah, we can handle that just with the A to D, this thing. We can handle it with this thing. What blew my mind back in the day was an FPGA that ran 50 megahertz, where you write a ton of code and all of it runs per tick. Yeah, FPGAs are nuts. It's field programmable gate array, so you can just reprogram the entirety of your device on a hardware level. All right, let's get rid of some of the excess around here. I'm putting together a schematic just so that when we get into actually building this thing, I can have a good analog of what it is going to be, and then we can see if our microcontroller is incapable or what. You know, if we run this circuit on everything, what happens? We can get down to brass tacks with a plan. Just get rid of this line that I drew around the whole thing. I like a good plan. It keeps me focused. You can see how unfocused I was by the beginning of the stream and how I kind of circularly rambled about what we were building. If I lay it all out on the table right now, then we're going to know exactly what we're getting into and how to hook it up and all that stuff. So we'll do a little bit of hardware planning here in order to save my bacon. I can also add more LEDs to this thing if I feel like it. I would love, I wonder if I should put some kind of RGB system behind the screen. I have something called the Tiny FPGA. It's basically an Arduino Pro Mini sized FPGA. It's pretty cool. I am wondering what I can eventually do with it. I was going to use it for my microphone system, but I didn't end up doing that. That's why I have this I2S analog or digital to analog thing. So this, hold on, plus minus 2 volts is not what this thing gets in. Plus minus 3 volts and 62.7K. And let's get rid of the underlines. 62.7 was the sweet spot. It's what I measured for basically tamping down the 3 volt plus minus signal out of this thing. And that basically means that we have plus minus 5 volts for a CV. Gate signals are often 8 volts, but they often make them more sensitive, so maybe we can get away with that without it being 8 volts. It would be nice if it could do plus minus 10 volts, and then I would have full reign. So let's just put a note on that. Well, no, that is, wait, plus minus 5 volts is 10 volts, but it should be plus minus 10 volts because gate signals can sometimes, here, modular synthesizer voltage levels. Let's double check our knowledge here. Oh yeah, good luck AI. Minus 15 to plus 50. Okay, so that's wrong, first of all. Euro rack. From Synth DIY. This thing is going to try to dox me. Hold on. Yes, come on. Pop it up. Pop up the... Come on. You love showing off my emails, even though I told you not to do that, Chrome. I told you not to do it. Okay, maybe it won't tell me. It's like, why don't you sign in with your credit card number? Here's your credit card number. Oh, and we need to go to pay. Starting to look at building some of my own Eurorack modules. I'm finding it hard to get a definitive answer on what the voltages should be. Blah, 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 blah. So CV, -8 to +8. Pitch CV ranges above 1 volt per octave, tune 0 volt to C3. Gate trigger on-off 0 to 5 volts. Audio plus minus 10 volts. No. The only standards are power is plus minus 12 and an optional 5. Signals should be 10 volt peak to peak. This applies to the CV and audio, though it can vary a little bit in amplitude, and there's some disagreement about whether CV should be 0 to 10 volts or plus minus 5. Yeah, pay Reddit. It was an old gateway, and they still keep it up. So if they get rid of old.reddit, old Reddit still works. Old Reddit still works. Why is it shocking to you that there might be multiple different ingresses into this system? I've been using pay Reddit for a long time. Oscillators respond to CV with an exponential 1 volt per octave profile. The average stable range is around 5 octaves, which is something that we should probably be shooting for our testing. I should be able to run it through 5 octaves by hitting a button. Gates and triggers are typically around 5 volts, but it doesn't really matter as long as they are at or above that point. Adhere to these loosely, and you shouldn't have issue. Sounds about right. I heard 8 volts for gates, but if gate voltages, I mean, CV would be the only thing that would get out into that 10 volt range. So our control voltage output should probably reach that range. That's going to limit the resolution when we look at an incoming signal, because if our incoming signal is just audio, it's going to be like well within that range. So, but our audio is plus minus 3 volts about, and then we scaled it down to 2 volts. It seems like maybe I just don't even need to have an op amp on the outside of this thing. Like these PCM 5100s are enough to just drive an entire output, because it'll do plus minus 3 volts, and that'll be acceptable for audio, especially given that audio sometimes can get into the plus minus 10 volt range. What, I mean, I have VCOs. Do I have any VCOs that work off the bat? I don't think so. Did Mutable make any notes about what the output audio signal should be? The one that I have is all control voltages, but we can find one, oh God, where is it? That's supposed to output clock out, gate out, DAC tone, reference, that's control voltage out. This one is tone out. No notes on voltage levels though, because I don't know what the DAC is putting out. It's 62 to 150 for that. Yeah, I don't have good answers here, because we've got a DAC right here that's 0 to 5 volts, but who knows what's coming out of this thing. And then it gets the DC component is eliminated, so that could be plus minus 2.5. But then it goes 62 to 150, so it gets even lowered from there, and then output, I don't know, 60. Well, 62 to 150 is sounding a lot like the values that I got, but what did Julian say about my audio? Didn't he say it was like too loud, or did he say it was too soft? Work calls, gotta run, have fun. All right, see Stratchen. All right, Stratchen. That dude is Stratchen all the time. I'll never install the Twitch app. Aw. You don't have to install the app. I go in from the web interface. Oh God, I didn't scroll down. Seen someone who makes an FPGA run versions of old game systems, like true to the original systems. That's cool. Yeah, that is very cool. Learning Verilog VHDL for them is a real challenge. Yeah, it is. Some of the hard-to-get chips for Amiga have been remade in FPGAs. Oh, that's cool. You got like 5 FPGAs in your Amiga. Your Amiga's full of FPGAs. It's too smart. It's too smart. There are no standards. CV plus minus 10 volt gates, yes, but in some EGs want more than 5 volts. Well, if we're capable of doing plus minus 10 volts on all of our I/O, then that should be pretty good. And then I could leave it up to whatever configuration in order to turn it into an audio output or whatever it's going to be. So let's roll with plus minus 10 volts. And we will configure our amps to do that using the stuff. Hold on. So this is going to be plus minus 10 volt. And we have 4 of those. Oops. And what we'll do is on all of those, we will both have an output and an input. So then I need a jack facing the other direction. Not the last time that I'll say I need 2 jack facing the other direction, but you know how it is. Let's see. So this one is an input, and I guess I need to turn it into an I/O, so I need a one that's facing the other side. I'm gonna have to steal it from the PDF files. I don't mean YouTubers, I mean just like the PDF files that we're using for the schematics. So let's take, yeah, that does sound pretty cool. Go to mutable instrument circuit here, zoom in a little, find a jack that's facing to the right. These will be I/O, so the left-right thing is not really all that important, but I would like to get one that's facing the other direction. Maybe I just need to draw it. I'm not up to drawing it right now. I've been drawing a lot of very careful things in the schematics, and It's been very annoying. Actually, what I'd love to find is one of these circuits that has a split kinks. I need kinks. Everyone, tell me your kinks. Wait, okay, so here we go. This is kinks. This is kinks. This is just designed to do a bunch of really crazy stuff with input audio. And one of the features of this thing is a noise generator. This is a 3904 based noise generator. What happens is the leakage, the millivolt leakage through this basically diode creates randomness, and that randomness is then amplified in order to make a random output. And so what happens is you can plug in an external audio that'll hit this sample and hold. The thing about op amps is that they're what's called high Z. When you have something that's sensing on a line, sometimes your equipment that's sensing on a line has properties. It has properties, and those properties can affect the signal. So if you have you're like, I'm gonna measure this voltage, bonk, and you bonk your probe onto that voltage, but your probe happens to leak to ground really, really severely, that voltage goes and it moves, right? So, well, I think it's white noise, but so what happens in a sample and hold, you can actually store a voltage on a capacitor, and since your op amp is high Z, you can hold a voltage on that line for days. And you can have this op amp using that voltage to calculate its output for days, because that capacitor has internal leakage and there's going to be very, very little leakage in your op amp. And so that capacitor will hold all that voltage on its plates and very, very slowly dissipate. This is also why devices are, like power devices, are very dangerous to immediately put out of service and then work on. Even like touching a screwdriver to the ends of a plug when it's unplugged can sometimes render a spark, because these capacitors will store that energy for an extended amount of time. We've gotten very good at building capacitors. So anyway, we take advantage of that with a sample and hold. So whatever voltage exists on pin 5, when we trigger this MMBF, this JFET. A JFET is a very low, it's a very triggerable device. Use a very, very low amount of current to throw this thing through and complete this circuit. That means that you're not influencing the level of your sample and hold. So what you do is you apply it to this capacitor and it pulls or pushes voltage onto that cap, then you cut it off, and because it's a JFET, this is a very strong cutoff, so it's basically like a floating circuit element with a capacitor that has a particular voltage charge on it. Try to breathe while streaming, bother. It helps if you breathe oxygen. Very cool little system here, and I got the privilege of going through Julian's kinks. That guy has some weird shit going on. No, I'm gonna stop making that joke. I mean, Gillette basically brought this on by calling this thing kinks. Why did you call this kinks? I guess because the outputs are all kinked around. But the point is, you've got a noise source up here. So you've got your noise source, then you buffer your noise source, you have a plug where you can plug into the noise source and put it into other stuff on your synthesizer. Then you have a potential to input an audio signal, and that audio signal that you're inputting or the noise can be selected in order to do a random sample and hold. So you can get a random control voltage out of this every time you trigger it. Cool system. It really is a cool system. Whew. But anyway, what's going on here is that the plug is being used to select between I or O. Yeah, don't open your old CRT. Well, that's a different thing. Opening your old CRT screen right after unplugging it, first of all, there are scary capacitors, but second of all, those tubes hold static. Anything with a tube that you're inducing like an anode and cathode energy into can hold a static charge on it. Lasers are particularly guilty of this. The old school people who used to work with tube lasers, when you're playing around on your shop desk, it's really cool. You're like, whoa, I got this neon lamp in front of me. That's really neat. And so you unplug everything, and then you happen to touch the anode and cathode, and oh, look, it's a couple kilovolts across your heart. Fun. I did that once. My hands like immediately went, bah, and I went, ugh, and then that was it. But I touched the yoke on an old CRT once. You do that once. Sometimes you don't do anything else after that. But yeah, your lesson is pretty strong. That was a hard hit. I mean, it was like getting punched in the chest. So let's just take this part right here and just taking it out that our signal that is going into a sense can come from here. Wait a minute. Hold on. Let me think about this for a second. If we're going to use it as an I/O, then we're just going to connect everything to the pin. Yeah, that's okay. Never mind. I thought we would have it so that if you plug something in, it'll cut off one part, but we don't need to cut off one part. We just don't use one part of it. Like those outputs, we will hold it ground, and then I don't know if we bother, because I'll have a buffer in there, so it doesn't matter. It won't feed back into stuff, I don't think. Well, we'll test it. I mean, we'll test it. We'll test everything. So never mind. I don't need this. I'm just gonna, let me just grab a jack from over here. Can I grab a quick jack, or is that against Twitch policy? You know, these jokes write themselves. It's not really me making the jokes. There's no brain process sort of in there. I don't think I need the resistor. I'm not sure what, I don't know. Actually, I need to take it with the resistor so I can get the full ground on there. I don't think the resistor is going to be a necessary part of it. I know there's 180 ohms for I and O on this thing. This one comes directly in, but that's got 180 and this has 180. But these are different signals. 10.4 on, 10.4 off. Yeah. Okay. I wish people who do circuits like this, and by the way, you know, they definitely don't owe us anything. They put all of these wonderful circuits out to the rest of the world, but I do wish I had more functional notes around some of these designs. Like, why is there a 180 ohm resistor there? What I'm doing is my typical MS painting. It's nice when you have something that's done in like AutoCAD, and then you can just kind of, I feel a little bit more free to author stuff when I've got it in MS Paint. I don't know if it's a short protection, inrush protection, maybe. That would make a little sense. So if I were to make this and properly communicate that this is an I/O, how would I do so? I guess what I would do is take half of this and flip it in the other direction. But since I can't, the values won't flip, like the text won't flip properly, I'll just do, hold on a minute. That's from there, and then this, yeah, this goes to the micro. So what we would have is, sorry, it's not a CAD, so it's a little bit clunky. Let's do it this way. It's like that, and then we have this. And then we have this. And these are all sharing the same stuff. And I'll have to invert this in software. Whatever voltage level I want to put out here has to be inverted. And then that 10 volts goes thinner lines, thinner lines, thinner lines. That's too thin. Too thin. Fine, slightly too thick lines. I don't like the MS Paint system where it lets you edit the trajectory of the thing afterwards, because if you hit escape, it destroys your thing. So you have to click somewhere, but sometimes when you click somewhere, you make another line, and then you have to hit escape. It's so dumb. So our jack is going to be permanently connected to both an in and an out. We'll have to see whether or not that's okay with the PCM 5100. We're going to have two of these. Oops. And then two gate inputs with a voltage measuring on it as well. So this will be times 4. I'm just kind of going to rearrange stuff until it makes sense here. Okay, and then we have 2 of these, so let me just get rid of this. I don't know what the diode was doing in the original ones, but I'm not gonna do the diode. Some of the later circuits involve a diode as well, but so instead we're gonna have that input with a 3904 on it, or no, we're not gonna do that. We're just gonna have this circuit. And we can just take in the microcontroller whatever voltage comes in and trigger a gate with that. Oh, that's really sloppy. I don't like it. Whatever. So that'll be 4 IOs with a PCM 5100. R or L. And then that means that out 2, how am I going to do that? Out 2, LR clock 2, B clock 2, out 1A, LR clock and BC, wait, clock 1, yeah, 1, 2. So, I2S 1, 2, using all those things. Yeah, I'm not gonna I'm just gonna mark the inputs that are used. So we're still clear to use A0 through 5. So A0 through 5 will be AN. And that's going to be from all of these. A in 0 through 3. And then this one is A in 4 and 5, yeah, 4 and 5. 4 and 5. And then we still have plenty of I/O left, which is good, but I don't know if we'll be able to do 6 buttons and 6 LEDs, and then that's 12, and then we have our encoder input. So I would need 14 digital pins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess 11, 12, so we don't have enough. How many are we? Wait, okay, let me recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, but we need the screen too. The screen's going to take up its own I/O. It's going to be asynchronous serial. So we're going to have a serial port for the screen. So yeah, I definitely am going to need, I'm going to need the port expander. So that means we're going to need I2C. So S clock and SDA 0. I/O. Yeah, so there's port expander as well. And then I need MIDI, and then I need an encoder, and then I need 6. Oh my god. I2C modules for extra pins, yeah. I have one sitting on the board already. Actually, I've got a bunch of these. They're not cheap, and they're kind of bad to be using in like a final design, but yeah, they'll definitely come in handy here. I guess if I was using this chip just right off the bat, it probably has a lot more I/O than what's expressed on these. And actually, I could access more. I could access more by using the back of the board. There's a lot of I/O on the back of the board. Yeah, Teensy 4.1 would be another way to do this. I don't want to spend the money. Also, Hans Sanitizer is a great screen name. That's a really good Twitch name. I probably already said that, but I keep an eye out for good Twitch names because, you know, I run a giant board that gets Twitch names burnt up onto it. That would be definitely would be a cool opportunity to get a gift subscription if the board was running right now, but it's not. That day will come. That day will come, and then I'll have to look at all my financials to make sure I don't accidentally get booted off the public health program in Pennsylvania. So yeah, what we ended up doing right now is just making sure that we have enough stuff to run all of our stuff. Part of testing the board in this manner is making sure that we're able to run all of the I/O at once. And I think that's maybe the direction that we need to go into, is making sure that the Teensy 4 can run everything at once. And I'm pretty sure it can. Where are we going to get a test program for the screen? I think we can just find something pretty easily. So this would be GU7000 and look up Arduino along with it. So let's do, oh man, more web pages to open up. Oh yeah, I'll start a new program too. Well, I guess we could just do... Yeah, this will be Teensy 4.1 stress test. Wait for that to come in. There it is. Save as Teensy 4.1 4.1 stress. And I'm doing that on the desktop just because my file server is inaccessible by this machine at the moment. Oops. .1 stress test. Run a, what was it called again? I don't. We'll have to look at the folder. I think I might have something that puts some noise up on the screen. It's true. I might be able to use I2C on the screen. It's got asynchronous serial though. Actually, no, I can't. It doesn't have anything with I2C in the datasheet. I can use asynchronous serial though. So, GU7000. Run a GU 140x32F VFD 2 PCM 5102s, an I2C port expander. What is the part number on the port expander? Port expander! Ow. 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 This thing is very... Ow! What's up, lawn dog? God, this thing... Paul Stoffrigan did a library just for that display? What the... Really? I bought this thing off of eBay. That's awesome. Okay. Our Lord and Savior, Paul Stoffrigan, once again, steps into the fray to have already completed all of the things that we need to do. MCP 2301. MCP 2301 port expander. to see MCP 2301. Oh wait, I already, yeah. I think that's everybody. Bad crash on modern insulin. I've had times where I started speaking gibberish to my coworkers. That was always fun. I hate that glucose in a tube stuff. It's disgusting. You have blah, GitHub, blah blah blah. GE7000 from GitHub, Paul Stoffrigan, authored. Second humble attempt to fix this library for non-AVR. Is this a hardcore library, or can I run this in Arduino? Nortec, BFD, Arduino. Wait, what are the two links? They're like the same thing, right? Oh, that's CUI and then GE7000. I have GU. I don't know if that's GE or not. Sorry, I can't read 500 messages. Let me go over and read 500 messages. Wouldn't have known what was going on last night until my mother mentioned it. Oh, geez. Yeah, you get, it's very common in diabetes to get kind of fighty because people start shoving stuff in your face because they know you need glucose. And for some reason, when the brain gets low on food, it gets very suspicious of everybody around them. And so that happens a lot. No, you spelled it right, Arduino, with a big letter R. Yeah, that sucks. You wake up from a dream and you're covered in cold sweat. It's like the worst. Absolutely the worst. It's like, cool, I almost died. Like, I love almost dying. Wait, that one, wait a minute. One was for, this is CUY. And this, mine is GU. And this one is GE. But it may work for the other ones. Well, hold on. Nortec, GU, Arduino. See, they have their own quick library quick guide, and I may have already gotten this one. GUD. Is this the good series? Not really. GU, something or other, 140x32. The good series. All right, let's get the screen working then. What? GE7000 has the same, no, it's this caps lock was accidentally on. GE7000 has the same command set as GU7000. Wait, but neither of these were GE. Oh yeah, GE7000. Okay, same command set. Okay, so this is a good. This is good. This is multiplying the amount of windows I have open. Let me just put this into the code. Put the link into the code. I have too many windows open. How is Paul Stoffrigan like so related? He does too many projects He does too many cool projects and makes too many cool things work that are exactly in line with the type of stuff that we like to mess with. We just keep getting running into this guy. He's everywhere. MCP2301 is an Arduino that's easy to find. The PCM5102 we have running through another Paul Stoffrigan project. And then the rotary encoder, we have, there should be a library for that. We also need bounce too. We can probably put most of the hardware down today. Let's get the screen running. Where are we going to run the screen from? So this would be an Arduino Hello example for the GE7000 VFD. We can take this and run it, and that will just get it functioning. Just get it functioning. Or we can start off with the Paul Stoffrigan library. Maybe we should start off with the Paul Stoffrigan library. Maybe it has better examples on it. And it'll probably clean up a lot of the sort of mess, this kind of stuff. So the Teensy has a library called Encoder. Yeah, I know it. Tools. All of you include library. Manage libraries. So this would be GU7000, no, GE7000, once the library manager opens up. I'm not wearing a watch. There it is. Oh boy. It's updating the library's index, which is completely hobbling the program. Oh boy, there it is. So we're looking up the GE7000. It's not particularly fast. Java Lang null pointer exception. Null pointers? Oh no! Do I have to manually install this? Yes, I probably do. GU140X32F, but this is by Hayden Clark. GU132F70 blah blah blah. Library implements required base methods for the Arduino graphics library, so you get all the facilities of the library on your VFD. It uses synchronous serial. Wait, ours is asynchronous. No critical timing problems, blah 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 blah. And then there's the Bill Perry's extensible. Neither of those are the Stoffrigan library. I hope I'm saying that right. I think I am. There's no, where's the how to use? I'm just tossed into functions to kind of, are there examples? Yes. Hello. I know. VFD begin 22. Interface. And then is this code just a copy of it? It's a pretty smart looking screen. Look at that thing. Beautiful. Clear redraw, acknowledgements, blah, 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 small fonts. Examples. This does a little bit more on the screen. I am tempted to use the one that's in the library manager already. It seems like there's more documentation to it. Albeit they both have very little documentation, but there's more examples here. I don't mean that as a slight on Stoffrigan. Well, there's a nice menu example. This is going to get really crazy in code because I'm going to have to do a whole menu system, and then I'm going to have to do like a way to change settings, and then I'm going to have to do a way to change configurations. All that's going to have to be loaded onto the EEPROM. This channel's providing much engagement. I want to build my own electronics station kind of thing. Hey, you know, something to give me something to do and learn and enjoy. I've got to build this workstation. Yeah. I don't know. You can get a bunch of disparaging tools. You don't have to necessarily build a workstation. Specifically, I mean, like having a shop bench. When you start out with electronics, I mean, having a laptop and a soldering iron is kind of where it begins on like a kitchen table. And the dedicated space follows when you start getting into, like, really getting into it. Detail menu, right align, number, blah, 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 blah. This is man, there's a lot of good stuff here. The screen's going to have to be its own thing. It's going to be an insane thing on its own. And I'm debating whether or not I want to use the Paul Stoffrigan code. Noritaki has their own examples, but they're pretty simplistic. Just a way to get a hello world to be on the screen. VFD.print. Hello, Noritaki. Step 3, select interface. Asynchronous, I see. Step 4, configure setup. Load into Arduino. That's pretty cool. I mean, they got a whole Arduino tutorial. That's becoming more and more common, where you have like somebody who's selling something, like a device with capability, and instead of giving you like hardcore microcontroller code, they'll go, here's how you do it on the Arduino, because you can get an Arduino out and just throw stuff together and see stuff work, which is literally what we're doing right now. I'm going to go with the code that's already in the Arduino. I'm going to keep my note here, but we're going to use Hayden Clark's library. Motion detected at the front door. Oh, my dog's not barking at it? Buff, who's there? Buff. Nothing. She's not barking for some reason. All the things needed, believe me, I do, except for a scope, which isn't necessary. A bench or table, it's issue. I have a spare bedroom. Well, that's one place to do it. Yeah, I mean, with me, like most of my workplaces where I've done the electronics work would be a coffee table in front of the TV, somewhere I could flip on something that's distracting while I do the work. Teensy's a library called Decoder. Yeah, okay, I'm already up to date there. Wait, why is this not? Why did these just like get annoyed and stop working? The VFD screens always look quite cool. See examples folder. None of those messages are coming through. Why? Probably because the pop under this thing is probably out of resources. Always look quite cool. No, that's on. It's just not on my. Huh. Always look quite cool is there. This thing isn't updating. I refreshed it, but that's the screen where I keep up with your chats all the way over where I'm looking has not updated. All right, anyway, let's go to file examples and then look for this. By the way, this Arduino install is getting old and tired. I should probably start over, but I've done some good stuff with getting the ATtiny85 things working and some other plugins that I've gotten working on this thing that were a little bit more complicated. But I guess it may be time to retire this one because this is just a huge mess. Maybe I should move over to the new UI. Cell Stepper, Adafruit, NeoPixel. I don't like the Adafruit libraries. I don't know why I have so many on here. Sometimes you have to use the Adafruit ones, but the Adafruit libraries are always very minimalistic. You're going to want to find somebody that has more time to spend. The NUI, the Ennui. Audio, bounce, capacitive, DMX. Gonna give it to you. Wait, no, that's X. Well, that's also D. Wait a minute. They're the same guy. All right, so Flexican, FNet frequency counter. Oh, we're going to need that later. I2C T3. Where the hell is this? What did I just install? Dog LCD. Do I have that? Dog LCD. I don't know. I actually don't know. Would it be in N for Noritake? No. No, it would not be. Well, it's probably way down here, actually. Arduino graphics. Timer, RC, JSON, bounce, ESC, fast LED, Gerbil. Really? No, I didn't know that. GU 7000, there it is, GU 14032. And there's also GU 7000. We were using one of these last time, and I forget which one it ended up being. I guess the Stoffrigan library I already had installed. LED backlight, onboard bitmap, proportional. And then this one is the GU 14032. I don't know which one I really want to use. We just do large text demo. Large tech deck demo. Okay, let's see here. Another thing from PJRC. Was that from the Teensy install? Maybe that's what it was. Yeah, because I don't think I have any of this stuff. We've got that dog in him. Okay, so what I want to do is I want to take the example and I'm going to pull it into our code, and then we'll hook up the hookups and see that working. In terms of power, we have 12 volts and we have 3 volts. We don't have 5 volts. I have a very big 5-volt power supply. We need to find a smaller 5-volt power supply, something that's just going to supply the Noritake screen with its power. So we need all this. So I'll make a little section here. I call that screen. And then I'm going to do that for setup and for loop. Uncomment the communication interfaces below. GU 7000 serial async, serial sync, SPI, parallel. Those are my choices. We're going to do async. We'll keep their baud rate for now. Oh, is that an, it's not just that, it's a type of LCD. I thought it was just generic LCD stuff. And then down there. And then setup. Take the delay out of this. I don't want delays. But since this is the only thing we have in here right now, we're going to start with that. Here's the problem is I have a 7000 and I don't know what this library is capable of. So I think we need to go into the library and actually take a look at what models this thing can handle. This is one of those annoying things. So enter the 4-digit model class number, e.g. 7040 for GU something or other 7040. See, the problem is they don't tell you with these libraries. They're like, put in whatever model number you have. And it's like, I have one that's barely even shown on the website. This one is a 7003, but it's also a GU model. Wait, this is a GU library. Okay, so it is the same library, but you know, mine is a 7000. And 7003, and I barely even see that one being supported. Let's see what they have in the library. I seem to remember doing this before. But let's take a look here. So I need to go into Arduino. So I need to go into folders, and I need to go into app data. So percent app data percent, because we're in Windows, and Windows works in such a way as to have everything nice and neat and organized and in a specific folder. Or it's in one of 12 different specific folders. Like instead of app data, it's actually in local app data under Arduino 15. Or maybe it's in roaming app data. Who knows? Windows sucks. Cache logs, packages, staging. Wait a minute. Nope, that's the wrong one. Local low, no. Roaming, I don't think so. Arduino 14? No. I think this one's actually in documents. Arduino. And then there's libraries in here. And then we look for, yeah, it's right here. GU, blah, blah, blah. Keywords, text. Nope. No, not keywords. Keywords doesn't have it. We're looking for source. And then C++, and that gives us a list of definitions. And so we can see where are we declaring the model number. Oh, maybe I need the .h for that. Draw pixel display. Yeah, this doesn't have it. Okay. Try this one. Oh, really? This one's Adafruit? Ah, I'm disappointed. Well, maybe it's a buildup of the Adafruit. That seems to be like it's very little code for what this is. GU 140327703A, which is very specific. Brightness on, off, live, clear, changed. Oh, wait, what library am I looking at? Hold on a second. Examples, and then we're way down here with this. Oh. We're doing the Stoffrigan one then. Oh, okay, never mind, different one. G7000. Here we go. Now there's so much more going on. Try interface, maybe? Nope, that's the wrong one. I'm looking, somewhere in this code, there's got to be a list of all the models that it supports. Back, forward, line, feed, home, carriage, cursor on, blah, 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 blah. Init. Set multi-class, 7000. Define custom care. I don't know what sets the 7003 from all the other models. I just want to make sure that it's supported. 7,000, 7,000, 7,000, blah, 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 blah. What do you guys think? Just, no, that's just config folder for the win. Yeah. Okay. Maybe you got it. No light, blue light, green light, cyan light. Oh, that's for if you have an LED. Oh, you know what it is? I think my model does not have the LED. I think that's what it is. And we can put in 7003 and see if it breaks everything. Yeah, I guess I could open them all and search them. Or we could just try it and see if it does it. Methods are the functions, they're not what's... Oh my god. Draw from image? No. Draw image. This is nicely documented. Fill rectangle, forward and it. Okay, so these are like how to do all of the drawings and stuff. They have different interfaces. What's up, Fames? Different interfaces depending on the exact number. Scroll up, and then from, I think this is drawing interfaces, and you were talking about something else. Some other thing that I opened up. Define custom character. Yeah, this is not in methods. Oh, on the website you linked. Oh, sorry. I always read the bottom comment, and it gets me in trouble. Part number ends with 7079, 7000 B, 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 C, D, 70037309. So I-80 type parallel, yes. UART, yes. UART CMOS, no. UART blah, 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 blah. And then the one that we have, 7003, UART CMOS and USART. What was USART? USHART, synchronous serial, and then CMOS level UART. S bussy. Okay, so that has to do with interface and timing. 7003 should be supported, I guess, I hope. I wonder if that means that it's in the serial sync, SPI, or async. Dear God. This is a lot. Okay, so let's oh, there it is. Lower reset, delay 1, raise select, delay 100. If get model class equals 7003, 7903, or 7053, while check bussy, else while not check bussy. Okay, so that's 7003 is known, it's in there, so we can use it. What's up, Brink? How you doing? We're getting into examples, so things are getting a little crazy. Okay, so we can easily then define 7003. Okay, oh good. 7003 is generation B. No. That out of there. Reset the module, initialize the module. Set font size, 1.1 normal, 2.2 wide, 3.2 wide. Sure. Why is it doing this all in? Oh, I see. So that's just what it displays. And there's nothing in the loop. Okay. So there's our screen test. That's all we need for the screen test. So let's get the screen hooked up. No, Ben Gizmo, what I mean is that my LCD is kind of a weird one. And so, you know, does the library support it is a perfectly valid question, because it, the interface could be different. It could be doing all kinds of different stuff. You know, I've run into this with things that aren't this screen with the examples in there. Sometimes somebody who makes a library is not in it to support an entire family of products. So instead, what they do is they make their library able to support the specific thing that they bought. And since there are so many sub-models of these screens, because they all do slightly different things, you could potentially have a screen that's not supported by the main library. And that's happened not just with screens. It could happen with any other of these like ASICs and devices that have specialty interfaces. Adafruit does this a lot, where they have no reason to go in and make a comprehensive library that supports a whole family of products when they're just selling one. And so they'll just make a library that does the minimalistic function so that you can test their one product. I was expecting this library to be like that. It turns out it's not. It does support all of the different LCD screens, but I had to verify and make sure that that was the case. Otherwise, you end up connecting everything and then your code doesn't compile. And you waste a bunch of your time. So that's what we just did. We just verified that my submodel is supported. Even like the Noritake like media and stuff like that, when I see people talking about it, like they don't talk about the 7003. They talk about the newer B model or something of that nature. So it's it may look like I'm being paranoid and I'm going in directions that are useless, but this is from a long career of messing up. Messing up in a particular way. All right, so we need hookup wires and I need 5 volts. Let's try to find a 5-volt module. Yeah, I've been hurt before by this. My heart can't take it. We need to find something that's going to make 5 volts. I know that this thing makes 5 volts, but it creates like, it can take in like up to 52 volts and it creates like amps and amps of 5 volts. We just need like a simple little 5-volt converter that we can put on the 12-volt line. And the question is, do I have one? And the other question is, did I label it properly? No, don't. Oh, I hate it when you do that. The divider came up. I hate it when that happens. In some of these bins, I've actually taped down the bottom of the dividers so that this doesn't happen. Lurk. We don't do the lurk commands. We don't do the followage commands. But it doesn't mean I don't love you. 5 volt. Oh no, 5 volt in, 12 volt out. 5 volt in, 12 volt out. How useless. Unlabeled. We should label this one. I need to print labels for these voltage regulators because they, like 12V doesn't really help me all that much. I think this is a 12 volt regulator. I just don't know what it's doing. I don't know what, like, the ins and outs and everything are always so confusing. This one I tried to write on. I think I wrote a number 5 on it, but we don't have pins on it. He's getting everywhere. I need to go through these and like actually give them little labels. I mean, I guess I could throw USB power over to it if the microcontroller is throwing out raw 5 volts. The thing is, in the final system, we're going to have to make our own 5 volts. I'm not going to have 5. I'm going to do the voltage regulator on this because this would be the first 5 volt device going into the system. And when this module tester module is in service, I'm not going to be plugging it into USB. What did I write on this? Here, let me move this bin to a logical location so that I can go through these and have the microscope up. So I need to clear off a little space on the desk. It's always so complicated. There's always so much mess. No, that's not a good place for it. I guess it's going to have to just go right here where it's going to be right under the microscope. C4, everybody run! That looks like YS7. That doesn't look like 5V. Two and a half volts. Oh no, it's a big 5. That's a big 5. Okay, so we'll use this one. This one will create a lot of 5 volts. I mean, it's probably goes up to like, oh, wait a minute. What's that dot right there? What is that dot right there? Why is there a little dot? Wait a minute. No, 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 no. This one might have blown up. This one might have been blown up. If there's a little dot right there, this one is definitely dead. Even the smallest GU7000 takes 175 milliamps. The largest can take 700. More than that can be drawn with the USB. Well, that too. That's right. I was going to try to make it into like a little chat screen, but I think the amp draw is too much for USB. I think this one is 5 volts too, but I don't have any markings on it. Put that one in there. This is one of the big bruiser ones. I don't know. Yeah, this is a 12 volt regulator. This is the minus 12 volt regulator that I used in the Eurorack module. I might build another one of those power supplies for the second Eurorack thing. That power supply was more expensive than your entry level PSUs for Eurorack. Oh, where did that one go? That one had a big blob on it, so I think it was probably dead. My power supply is more expensive than like entry level Eurorack power supplies, but it'll be able to power a whole lot more and be a lot more stable. So it wanted to be a whale. Well, that's the magic hole, the magic smoke hole. Don't start talking about my smoke hole. GU 14032 7003 4G50 F100. But GU 14032 7003. Absolutely no idea what this one is. I'll just go back. This one has sticky, oh, it's nasty sticky stuff on it. Looks like I cut it out of a different project. Ew. It's covered in slime. What were you doing in a previous life? Oh, it looks like drone stuff. I was very careful to have, I can draw up to 480 milliamps. Jeez. Well, that's what we were going to find out, is what kind of a burden on power this is going to be. I don't know what voltage this is, so this one will go back in the bin. It's probably going to be 5 volts, and it was probably used on some kind of a drone project. Oh, you know what? I got this out of that robotics controller. I was going to use that to fly drones. I bought this, like, whatever it was, Kickstarter robotics controller. It's a nice little thing. It's a nice little controller. I want to get it running as like a joystick, because there were some RC games that came out recently that would really benefit from a controller like that. LM 1117, but then what's after the 1117? I can't see. This is probably 3 volts. I think I bought a pack of 3 volt regulators. The lesson of today is to label your regulators, folks. Put a label on them so that you know what they are. I guess you could always try powering them, but some are more sensitive than others. So what I'm really looking for here is a voltage regulator that already has pins on it, that will output 5 volts, and isn't too much of a bruiser for me to use. This one isn't even... See, this is from me from later actually labeling my stuff. 2222 with a B, C, and F. Or B, C, and E, rather. It's just this little surface mount 2N22222. No. These are all... Actually, what we could do is I could take the LM117 out and put a 5 volt LM117 on this. Let's do that. Let's say I have one that I already did that to. Doesn't look like it. What about this one? Wait a minute. This one also said... Oh no, this one is... Yeah, this one takes 5 volts in and outputs 12 volts. So this would be if you have something that takes 12 volts that is sort of a lower power system, this thing can provide, but we don't need that. It is the opposite of what we need. We need the opposite of that chip, and I guess we'll achieve it by doing an LM117 And I'll do that by displacing this LM117. LF, LM, I forget. I don't like the 7805. I don't like it. I don't like it. You can go kick rocks for all I care. It dumps too much heat. Like when you use it at an amp, it gets way too hot for any of the little projects that I do. All right, so this is like the most impossible to read part number. I don't know why it's so difficult to read. Let's get some like angle light on it. That is way too much light. So there, let's see, AMS 1117. This one is, see the number down there is 3.3. So we're gonna find one of those that is 5 volts. Two 7805s in parallel. Doesn't that mess with them? And then if one fails, the other one really fails? It's like, well, I guess I'll die. One of them hates it, but it works. I'm not doing that. We have standards. Let's see. Somewhere around here, there's going to be a bunch of ones with a 7 after it, and then it's going to say 5V. I have so many op amps now. Those are all wire stuff. Nope. AT-Tinies. At Mega, these are all brains. Here we go. Here are voltage sources. And no regulators. Okay, fine. They're all ASICs. See, I have 5 volt reference, 2.5 volt reference, and then 10 volt reference. A lot of these are not really that necessary, but if I really need to, I could do an analog voltage reference. The Hotech HT75. I may or may not have used those before. The 7805, I have bins full of them. I've got plenty, but I just don't want to use it. So adjustable, adjustable, adjustable. That one is 5 volts. This one's 1117 SOT223 5 volt. I have a lot of them, apparently. I have them in 2 different sizes, in fact. One I have in the very much heat dissipation package. But in this case, this is dead. That one just goes over there. So I guess what I'm going to do is swap... Oh, what's this one? Oh yeah, we didn't know what the identity of this one was. If this one is a 5 volt regulator, it might be a 5 volt regulator. It'd be very useful to use, but I guess if we get closer to 1 amp, maybe we'll want to mess with that one. But why the 7805 hate? I just don't like how hot they get. They get very hot in any application that I've used them in. I've used them in a lot of stuff, and I have a lot of them. But they're not low dropout. They're moderately wasteful, and they get too hot. That's why there's hate. Chat, your hate can be valid. You know, it's healthy to hate. Yeah, a big heatsink or an outer wall that's made out of metal. All linear regulators are equally wasteful. I'm not saying use a different linear regulator. I'm saying use a low dropout. All right, let's get some heat on this, and then I can pop this thing out of here. Because this is the 3 volt version of the LM1117. We'll put in the 5 volt version, and we will see if it can handle 400 milliamps, which is just about half of what it claims it can handle. We'll see if it gets super duper toasty. I'm stalling right now because I'm looking for my tweezers. Where are my tweezers at? Where'd they go? Oh, they're literally right in front of my face. They were the only other object on the desk was my tweezers. Hot air on. This over here. Low dropout are still linear unless you have very low input voltage close to the output voltage. They have no advantage. That's not my experience, but you guys always have to counter what I'm saying. Even if it's an opinion. Put this away. Just fluxing it a little bit because this thing is designed to dissipate heat, so. And we just kind of slowly apply heat until this thing is ready to go. In which case, it'll still be very, very hot for some time. This is a fixed 3 volt. I'm flipping it for a fixed 5 volt. And it's in a convenient little board like this. So it's easier for me to do this than to test that other board that I think might be 5 volts. That other board can probably handle 2.5 or like 1.5 amps. But I know that this thing will be able to handle 1 amp. So I could technically just swap it using hot air. Maybe we will. I'll bring the iron in for just a little touch up. Of course, this is kind of dangerous because we're flash heating this thing. 1117 is a tough little regulator, though. My handle isn't properly positioned for that, so it wandered all over the place. Yeah, I've kind of got to be far away because of the hot air. So you know what? I'm gonna just solder this. I'm not gonna use hot air. Oh, now I have the problem of it not moving away. Shit. All right, fuck it. Nope. Nope. That didn't work. Let's just let everything cool off, and I can get the solder braid out and just clear off the pads. It's much easier to do it this way because I can put my wrists down on the desk. If I can't put my wrists down, it means that I float around all over the place. So it's better for removal. Yep. Who's arguing against Ohm's law? What do you... Look, I'm not feeding that one. I don't know why you guys think I'm... It's this tendency for you guys to, like, overanalyze every single thing I say. Let it go. All right, so I guess I'm going to solder using the big tab, which is generally not advisable because the big tab is where all the heat's dissipating. So if your iron is good enough to hold all the heat into that, that's fine, but... Or do you want to argue against that point that I just made? Go ahead. I want every conversation to be a fight in this channel. All right, give the big tab some love. I'll hold that down. I love arguing. I'm not strong enough to argue about everything. That's my problem. I come in here with knowledge on how to do this kind of stuff, but I'm not a lawyer. And you guys have Google at your fingertips. So I get people who come in and try to remote. Where did my circuit go? Let me go. This is going to be hard to touch. Ha, ha, ha. Ow. Owie, ow. Ow. Owie, owie, owie. Glowy hot thing. Streamer, get angry. It's funny. Well, yeah, that's why I get angry. Are you really coming in here doing boomer wife jokes? Every conversation should be a bite. Yeah, keep it succinct. Learn from Twitter. Everything should be a limited number of memory space. You people come in here, say 1A, 2F, and then I have to argue against it. Can you believe that bite? 3C? I don't know about that. Breadboard? What are you talking about? All right, just making sure that the solder's pretty, and then we can put this on the board and we can get that screen running. Just one more yak, bro. One more yak. I swear, bro, this is the last yak. There's no more yaks after this one. It's just, bro, just one more. The component is an SOT223, so it's in that standard. SOT223. It's the LM1117. You can look up the specific part number. It's a legendary voltage regulator, second only to the 7805 in its popularity and fame. But it's a good little regulator. It does stuff pretty efficiently, and it doesn't get too hot if you don't push it. That's all of them, but whatever. Okay, so where are we doing? I'm going to leave room here for the second I2 whatever interface. So the 5-volt regulator, we can put, I guess, up here. Wait a sec, what part number? The port expander might also use 5 volts. The yak peeling zone. Yeah, this yak is so shaved that I think we're doing laser hair treatments on it at this point. This would be the MCP2301 is the port expander that I have in abundance. So let's see what voltage that runs at. Look at all these tabs. I'm doomed. Chrome is going to eat my computer before anything else. 230117. Less messy to peel. This is we're getting into the realms of we should have peeled the yak, but we haven't because we've been incrementally getting more and more yak hair out of this thing. 1.8 to 5.5, 2.7 to 5, 4.5 to 5. What is it like? Can it run at 3 volts? Min is 1.8, max is 5.5. Usually the top of these, so data sheets take on different forms, but generally, if it's a well-constructed data sheet, there's no laws behind like data sheets. Data sheets aren't regulated by like a governing body or like a police force, maybe secret alien police, but like nobody's regulating these. This is just sort of what has been fallen upon as the structure of a data sheet. Generally, what you'll get is the first things you get are bullet points that will give you all of the characteristics that set this thing apart and give you a general idea for its use. Microchip has decided to put pinouts at the very beginning, which is always nice. That's not always the case. Sometimes you get characteristic tables first. Second, they go into a block diagram of how the chip works. That's not typical. So usually the next part of the data sheet, right after you get all of the initial sort of characteristics, sometimes you'll get like a couple paragraphs justifying what their product is. Usually though, one of the first things that you go into are characteristic tables. Characteristic tables, well, aside from an index, yeah, I guess sometimes you get an index too. Characteristic tables will give you the electrical properties of the thing that you're putting in. If it is a digital device, they will usually start by telling you what the I/O voltages are, what the main voltage is. That's what you look for in the very beginning of the sheet. So when I got into this data sheet, I jumped in and I looked at whether or not the the pinouts and the functionality agree with what we have. Then I went and looked to see if they list operating voltage at the beginning. They sometimes do, they sometimes don't. In this case, they say 1.8 to 5.5. Now that is an operating voltage, but sometimes they take some liberties on these things and they don't give you the full story. So high-speed I2C interface, 100, 400, 1.7. Well, what does that exactly mean? So in order to find the voltages, I'm scrolling down and I'm looking for some kind of a table. And immediately I run into the DC characteristics table. So then at the top of that, it just says supply voltage. Okay, cool. So now I have a min, typical, and max. They don't have to put a typical in there. If they had, then I would know that this is definitely the voltage that this thing wants to run at. Instead, they give me 1.8 to 5.5, which means that it's okay to run at 3.3 volts, which is what the rest of our system is. So we will be running that at 3v3. So let me just go into our plan. And I didn't mark it down yet. So I'll put a box down. And we will call this the MCP 23017. 23017. So as we're shaving a yak, we're also doing stuff that's going to be useful later on. Yeah, I2C. So SDA, SCL, and then I'll put ground and power and mark that as 3v3. I do that because I might as well draw a V with the mouse instead of drawing a dot and then a V. It saves, with all the time that I've saved doing that. And we'll worry about what the pinout over here is later, because this thing is it's an IO expander, so naturally it is a ton of IO. There's a B and an A bank, so there's 2 banks of 8 pins, which is very nice for us because we have a lot of LEDs and we have, well, six LEDs and 6 switches. We will just do the arrow thing. Doot and doot. I already have ×6 on there. I don't think we're going to do an encoder with, I think we'll do the encoder directly into the chip, because that way it'll be able to influence it a little bit better. Everything gets 5 volts. Let me smoke out and replace the component. Everything 5 volts. I don't think anybody's done that since the 7800, or no, 7805, no, not 7805. 7400. Since 7400 logic. You get everything in TTL. That was fun because when you do stuff all in logic gates, you can put LEDs on everything, and then your electronics circuit like blinks away. It's very nice. Very cool looking. So we still don't have a voltage regulator. We still don't have a voltage regulator. Okay, so the MCP 23017 does not need 5 volts. I was kind of hoping it did, because that would mean that it would justify our voltage regulator a little bit more. The voltage regulator, as it is right now, only exists to power up the screen. And so we're going to get our little text demo on the screen. Let's hook up the LM1117 and see if it doesn't blow up when we power this thing. So, LM1117, we should just add this to the other, well, we'll do the hello world first, and then we'll, yeah. Hello world first, and then we can jump over to the other stuff. Oh, and I wanted to measure this to mark it down. Too many different directions right now. And the screen will be plugging directly into the Teensy 4. There and there, and we're at 18 kiloohms. So 18.87 is what I'm measuring on this potentiometer right here, and that's for the input stuff. But then again, I'm probably going to need to recharacterize that, so maybe it's a little too soon to be measuring, because I want it to be able to take in 10 volts. I don't know if it can. I think I can only do 5 volts because I've got that fixed 10 volt regulator. And if I change that ratio, it's going to mess with it. It'll go into the negatives when it's very positive. Where's my drawing? There it is. I'll just mark it down there in case. I know that was 18K. Question mark. I may have to revert it to 1 to 33, and that would mean that we wouldn't be able to measure gate signals coming in, because gates can be 8 volts, potentially. But they said more than 5, so if I measure something there, I can say it's less than 5. I don't know, we'll see. There's going to be a lot of coding. A lot of coding. So, screen. Didn't we find something about the screens where it had to be a particular, like, baud rate or else it would get kind of squirrely? I don't remember. I feel like I'm running into all the lessons that I ran into the last time we did screens. So Teensy 4.1 stress test. GU7000 async 38400 baud. Pins, what, 357? Sin, bussy, and reset. The bussy tussy right there. So sin, busy, and reset. I think those are any pin pins. So let's check on the 4.1 where we want it, or sorry, the 4.0 where we want it to be connected. My brain is like a first write situation. The first information that gets written is what is permanent. And so if I get it wrong, it's permanently wrong. Some of these are not useful. Hold on. I need to close a lot of these extra windows. This is where I would check, but we have a drawing that has it all on there. And there's the sound stuff. More stuff with the Teensy. These are all these tabs that I have open that I'm not using. Guess we'll close that one down. I don't need the design stuff anymore. We've gone through and we figured it out using the legendary mutables instruments stuff. This one I do still want open because this has the functions. This is all like all the stuff that it does. That's the M303. I guess I can close that. This is the document that tells you all the math behind the penis ladder filter. I mean diode ladder filter. There's a Hajiwo. Okay, so we've lowered my anxiety by reducing the number of tabs. Okay, so I need my drawing, and we need to find, well, 2, 3, and 4 are in use. We can't use those. All of them are PWM capable. We have a TX and RX serial right here, but I think we should bust down to these pins. So chip select, MOSI, and MISO are 10, 11, and 12. We're going to be using an I2C, so the IO expander's up here. All of these are needed for analog in, but I guess these two will have to be 9 and 8. Because of I2C. That's unfortunate. We lose some of our analog pins, but we'll get over it. So we're forced to be over here, and we need bussy. Where are we? We're over. It's bussy, speeve, sine, spuzzy, and reset. Signs, buzzy, and reset. Oh yeah, that was in the code. Sign, pussy, and RST. We'll just do them like this. Sins, buzzy, and spuzz. Okay, so. And that's going to be 10, 11, 12. So we just change that to 10. Well, actually. Oh, I see. That's not going to be set up yet. Well, we still need to have pins. We'll do a pin section. And then define sin, define pussy, and define, let's do GU RST. So I'll define those as GU underscore. And then 10, 11, and 12. Nice and easy. Save that real quick, and then that's going to be takes a nice long. I like a nice long save. That's going to be juicing. GU bussy. Get that bussy, and then GU reset. So those are our pin assignments in there. And then we'll do settings. And then screen and define GU baud, and that's 38,400. Gubad. There. That's more like real code. Let's see. In settings, let's do general, and then define PU delay is going to be 500 in milliseconds. Boot delay. PU delay. I don't like having that power-up delay in there, but I guess it's what it's. Pins, settings, screen, define, GU width, whiz width is going to be 140. Define GU HEI. HIG, whatever, 36. I can't stand not having this in proper coding format. GU wid, GU hig. Interface is selected above. GU model. G7000 reset in it, and then those are just for this test, so I guess we can leave them in there, just font sizes. And then the loop does nothing. Okay, so that's our test program. I've taken it and I've peeled everything out of this into proper coding parlance. And this would be model number, and now save. That's going to take a half hour. Dead chats. Nobody's talking because Bother is working, and he's scared everybody else away from actually talking. Everyone is afraid to say anything in Bother's chat. Where did that voltage regulator go that I desoldered? I was going to put that away. I don't know what happened to it. It's gone. Under the mouse? No. Am I wearing it? It shouldn't have gone far unless it's stuck to the clamp. I am busy. Yeah, people got work to do. Thursday. Thursday is the rush before Friday. Monday is when everybody gets in with a fresh face and toodles around long enough, but Friday, like morning, is when a lot of work gets done. But those who are slightly more, oh, here it is. Just slightly more organized. They're doing all that work on Thursday. So this is a big day for people to get things done. I only have 2 of the 3-volt ones. That's not good. I was on the phone with my doctor. Well, you didn't ask to be excused. Man, some of these chatters will tell you something. All right, let's get this LM1117 hooked up. My butt hurts. Maybe I am your dad because my butt hurt. All right, anyway, let's get this thing over here. So what's my motivation? Oh, here we go. VN, out, and then ground. Cool. We've got that all labeled up. So I'm going to put that actually right here with all the labels. The power is going to be all the way over here. It's just something about organizing these breadboards. Let's move my scope probes out of here. And this little jump, I guess we'll leave this little jumper here because that's for my op amp testing. I'll get back to that. Okay, so the screen, how am I hooking it up? I think those are header pin sized. I mean, this thing could practically just plug in to the edge of the board if I knocked off the back piece here. But I kind of want to preserve that because I think I have a set of wires that I could use for this on the final thing. So does this work? Pretty handily, actually. That's nice. Okay, so what's my pin out? You guys are getting way too into lore over there. It's making up all this lore. Okay, I need jumpers. Jumpers. Yumper. Yump. Jumpers. Go. So the Fallout London came out, but I'm not sure if you need to downgrade your client in order to use it. I think there's a downgrading tool. So instead of making it work with the whatever new system they put into place, because Bethesda monkeyed around with how everything works, and everybody's mods needed updating. But for Fallout London, I guess their whole project got completely like derailed by this thing. But I don't know if I want to play or not, because it's not one of those mods where you go find the guy that'll then transport you to where the mod is. It's one of the ones where you start out with a whole new character. I don't know if I have that in me right now. I think I need one or two more. How many do I need? I need the 3 signal lines, and then I need power and ground. So I need 2 more. 2 more. And also, Fallout London breaks one of the, what I consider to be canon of the lore of Fallout, is that the only place that's super, end of the world apocalypse, and everybody's running around with guns shooting each other and raiding and stuff, and like this horrible reality, is only in America, and everybody else is just fine. Everyone else is just fine. They're just going about their day as normal. Oh, America? Yeah, it's post-apocalyptic over there. Don't go there. It's pretty bad. They don't they have less than healthcare. They're all shooting stim packs and breaking into 200-year-old safes. Want to go get a cup of tea? All right, fine. This one doesn't have a header on it, but if it's the only one that doesn't have a header, it shouldn't cause any problems. So what am I plugging into here? I need to go to my document here. So those are the pins, pin 1, 2, 3. Luckily, these are all labeled. I love that there's so much support for these screens. So VCC is going to be pin 1. That's over here. So that's going to go to out. And I don't think I'm going to send anything down. I'm not going to use that. But it's going to be these 3 pins here. That's going to be a little bit messy, but I guess just for this test, it's fine. Where did I get the idea that the rest of the world is fine in Fallout? Because they don't reference anything external to America. Sometimes they talk about Philadelphia and, stuff like that, but no, Bethesda's not going to make a Fallout that's anywhere other than America. Makes me think of the guy who nicknamed himself Yak because he shortens the first word of Insomniac Rap. He makes up words live and without cussing. Does stuff like crossword puzzles at the same time, or forms random words folks type in. Have I heard of this? I might have heard of this before. I love VFTs too, just wish they weren't $200 per unit. Yeah, I know. I bought this one off of eBay. BCC, then we go Sin. So that works. Sin, then Ground. Odd layout. We'll just get our power from over here. And then Bussy. Bussy. Oh, and actually it's going pin 13 is Sin. 12 is... Oh, this is a bad one. There, and then... Oh, this one's actually... let's replace this one. It's very short. Both of these are. I would like them to be this long. That way I can get my screen well out of the way. Fallout Some City I've been to. That's the thing. Todd has said that, you know, the Bethesda Fallout games are all going to be in America. So there's a chance maybe they would hand the buck over to another developer, and then we would get something in a weird location. I would love to see Fallout Philadelphia, but that's not exactly, you know, that's still on the East Coast. Fallout Colorado Springs, something weird. Let's make Ground the black wire, even though these are very hard to differentiate. You know what, now. I need one more long one that has the pin on the end. Where would they go for the next one? I wonder. So it's Bussy, NC, and then reset. Wait, it says NC, reset, NC. Huh? That's not as many pins as I have here. Asynchronous serial, pin number 1. This is 1 to... 2, 3, 4, 5. This is 1 to 6. What I'm looking at is 7 pins. Plot thickens. We need to look up this screen again and figure out what the pins are. I got the wrong pin out. Unless the NC just isn't there. Fallout Philadelphia, look out your window. What's the difference? Yeah, listen, I know it's politics season, and that clip of the one street in Philadelphia right by Temple University is circling all over, and everybody likes to think, wow, Philadelphia is a total shithole. It's not. It's an actual very nice city. It's a very, very nice city. There's just one street where drug use has been all but legalized. It's not, but it's still a place where everybody seems to love traveling to in order to do whatever the fuck is going around right now, which is some pretty crappy stuff. Pretty bad stuff. 7003, but not D. Where's 7003, but not D? See, this is what I'm talking about with looking up the screen support, is that I'm not finding 7003B. There, 7003. It was like the first one they ever made. Detailed data sheet. You son of a bitch. I hate it when they make you do that. Wait, that's not the model. Oh, it's a different, yeah, 280X16G. Oh, geez, okay. We need the 140, but in 7003 flavor. 14032 7003D. There's no other ones listed on here. Like the specific one that I have does not have the letter D associated with it. But I guess NA, okay. And then I can't get the data sheet through there. 7003B, 14032. Where's 32? 14032, 7000, 7003, 14032D. Nothing there. 14016, 128. Wait, what the hell? Wait a minute. I'm 128. No, I'm 140 by 32. 14032. 128, 112. GU 14032. 3D 750. 53, 64, 79, 7903, 7950, 7003D, only one listed, only the detailed data sheet. I don't get any other. I guess I could look at the B, simplified. It always has to download it. So that was the one that I was looking at before. 1, 2, 3, 4, 5, 6, 7. That has 7 pins. 1, 2, 3, 4, 5, 6. There's a pattern here. Even GTA is depicted in the USA. Places around Los Angeles depicted I recognize. Used to drive all over the place when I was installing internet backbone stuff in a telephone company's central office equipment buildings. That would have been a bucket list, trying to see all the hardware crammed into those spaces. Yeah, too bad the buildings were just like loose polygons. Yeah, I was living in DC when Fallout 3 came out, and I was able to actually go to where I lived in Falls Church, and it was just rubble. It was flat rubble. There was a little bit of a curb there, but like my whole neighborhood was like a city block, because they super condense all of the stuff in the city because you're on foot. So they want you to be able to see everything, but they don't want you to have to, in real time, walk, the National Mall. Because the National Mall is very, very large, and they don't serve food there. You can go into the museums, and they might have a burger that you can get, but it's like a $16 burger. It's like, well, at the time. Now it's probably like a $20 burger. Yeah, you don't want that. You'll want to get food before you go and visit all the stuff at the National Mall. And then you need to prepare for a day of hiking, because you will be on your feet the entire time, and your feet will hurt afterwards. It's a big place. Fascinating, but it's a large place. So what the hell? I mean, I could just like look at the pinout and maybe we'll get it correct. I don't think they would vary very much. It's kind of criminal that they put these all in the same series and they're such different products. That's definitely a power pin. Like, what is this one? That's power ground and then one data pin? I wonder if there's some kind of a data standard there for like using only the 3-pin one. There's a fuse. Made in Japan. And I don't know what we need to do with the jumpers. This only has one connector on it, and it's right here. It's CN2. So pin 1 is definitely power, 2 is a signal, and then 3 is ground. Gerb. Up here, we have what looks like a parallel interface. That's it. That looks like parallel, 14-pin connector. Down here, we have serial, but we don't know. Oh, there's nothing installed on there. That is open. What about on the other side of the board? I don't see anything going to it. So 1, 2, 3 lines that potentially do something, and then NC on that pin. I need to find the answer. I don't want you to give me the answer because I don't know where the answer comes from. $20 burger. I mean, I'm just coming up with a number. Please don't quote me as being factual. It's in the rules. If I say anything wrong, it's just to test you guys. Much talent loves birds. Insomniac. Okay. It's not jumper resistors. There's literally jumpers. So I need a little bit more data. 7003D. I don't. Well, let's look up the part number. Maybe somebody else has the data sheet. GU 7003 data sheet. app note. And then how to set up test mode. Graphic display. They're probably not going to be going through a pinout. Oof, a lot. One, two, three, 4, 5, 6. Well, if I were to guess, I could guess about this pinout. Pin 1, 5 volts. Pin 2, something. Pin 3, ground. Pin 4, something. Please validate circuit design to meet the host circuit spec. Okay, so that's not really going to give us that information. Yeah, some are the 5 pins, some are the... Oh man, there's all kinds of stuff. BFD display modules from Advonics. Not that. You've got it on DigiKey, I see. So this is from DigiKey. This is a 7003 14032. This is why having DigiKey archive datasheets is nice. I remember this datasheet. Wait, this one is a character display? Character graphic transformerless. Oh, I see. Okay, yeah. So we can also do graphics on this. Very thin viewing area for what is, you know. Yeah, DigiKey does have a lot of stuff. A lot of good stuff. I would love to have this thing poke all the way through, but what's interesting also here is that they've got a little nub on their data sheet where there's no nub on this one. Weird. Weird. So, I mean, the pinout for the serial connector, SIN ground bussy NC reset. VCC SIN ground bussy NC reset. This is the simple data sheet. Oh, look at that. Yeah, they don't even tell you the connectors, like here. And then this is not in the wrong place. No, it isn't. Never mind. I'm taking crazy pills. All right, so now we can get this thing hooked up. Yeah, I should have looked at DigiKey from the beginning. In-out ground, okay. I guess I could put this supply, I could sneak it in right here. Then all our pins are at nearly equal lengths. Of course, I need to connect this to positive 12 volts, so I need to move this to the middle of the row. Give me this, give me this. And then I'll do this one for ground. So ground here, dark gray. These are, I don't know, these jumpers are so dark. It's hard to differentiate between them because my light isn't as bright as it could be because I haven't pulled in the stand light. All right, so our code assigns pins to, hold on, gotta go over here. 10, 11, 12. 12 is RST. And reset is pin. And actually, you know what? What I'll do is I'll take this, snip it. We'll take just the serial connector. Please inquire for final specification. They keep passing the buck. Nobody will take responsibility here. Okay, and then let's see what our specifications are for I/O. Do we get voltage levels on this? No, I need a better data sheet to do that. Hopefully it doesn't blow up the microcontroller, because the microcontroller is not as expensive as the screen, but it is a little bit more precious. Since I have replacements for the screen, I don't want it to blow up my micro. Well, we'll just have to trust that they're not using full TTL voltages. What the? Oh yeah, there they are. Never mind, I glossed over it. 3.8 volt DC minimum for the logic high output. 3.8 is the maximum voltage that the Teensy can take, which is a convenient number. They're the same number. That's kind of convenient, but it's a little bit concerning, but I guess we're okay. Push comes to shove, I guess I could put a Zener diode on the output or something. Okay, so 10, 11, and 12. Let's just get all my data up on here. Where'd my thing go? MS Paint. There you go. Okay, so VCC. This would be. Oh wait, that's it's actually ground is up here. This one's V out. So VCC is pin number 1. It's over here. Pin number 1. VCC. Pin number 2. Thin. Pin 10. Pin number 3. Ground. This one here. Pin number 4. Spuzzy. Bussy. Five is no connect, and then 6 is reset. And then all those, I'm going to anchor out of the way over here. So let me take a yumper. Hopefully this will be strong enough. And just put it right over top of this. And that just keeps this from getting completely swamped by all the wires coming out of it. Okay, and now we need a jumper that's going to go to power and ground on the voltage regulator. And power plus 12 volts, where's that coming from? From right in front of it, I believe. Yeah, plus 12, ground, and then minus 12 is all the way down here. And then I've got another minus 12 up here that's powering this thing. And the op amp. No, that's going to ground. This is going to minus 12 and ground, yeah. That's just our 10 volt source. Probably should move our 10 volt source here. That'd be a better place for it, huh? But then minus 10 only goes into the input amplifiers. And the input amplifier I wanted to keep close to the micro. Whatever. It's all so confusing. So I need a yellow yumper. Sweater if you're in England, yeah. That one's going to a V in here. I need tweezers to do this. All right, Ben Gizmo, have fun. What's up, Christopher Estrada? It's a wire swamp. Yeah, things are a little bit messy on this breadboard. This is what happens when you build something as complicated as a module tester for Eurorack. It's already very complicated, and this just kind of balloons the complexity. And especially working on breadboard is the way you should do it, because you can reconfigure stuff on the fly, but it comes with its own host of limitations. That's V out. I need V in. Wait, I just hooked V in into ground. Do. Am I stupid? Okay, so V in to 12 volts. Now I need ground to ground. The way I configured this breadboard is that I was going to primarily be working on this row. So on this row, I had plus 12 ground, and then another ground, and then minus 12. So it just goes in order of voltages there. And that way, when you plug an op amp in, you just do the plus 12 and minus 12. Okay, I mean, all things considered, I should probably move this on its head and put the micro down here, and then I could have the outputs to the screen go like down and around, and you know, there's a million ways that you can configure these things. It's just, yeah, V into ground. It's, well, that would the power supply helps me out here. It helps to have a lab quality power supply in your setup because it's got current shunt abilities, and you can set it to only allow a certain amount of current to go into the thing you're testing. It's a thing that I don't do often. I don't remember to do this often, but like when you test a new device or a new circuit setup or a new whatever, you limit the amount of current, and that way if something goes wrong, as it inevitably does, it won't explode everything. But being, you know, streamer boy, I need to give everything the ability to explode because that's what leads to viral clips. In a real bench setup, really actually developing stuff with money that isn't yours, it pays dividends to be cautious. And obviously, if you're not, you will eventually learn to be, because things tend to get wacky. Okay, so probe pins. This came out. That's my positive 12. What are you doing over there? Yeah, I've been through the ringer on all this stuff. You plug something in and you set it to like 500 milliamps, and then that's enough to like blow up a major circuit element. It's like, what have I done? Why am I dumb? Why are you dumb? Okay, let's get this one out here. How's everybody doing today? I don't really mean to be super mean. I'm just trying to get by. It's tough when everybody tries to remote pilot the streamer, and I know that just means you guys are engaged, and I appreciate that. I appreciate you guys being engaged in these projects that I work on. But we do things in a little bit of a haphazard sort of way here in order to make it fun and fast. Things happening quickly around here. I've exploded several things at work. It was amusing to the companies. It was amusing. The companies never cared that they lost a little equipment. It depends on where you work. I'm going to tell you that much. It depends largely on where you work. There you go. In 2 comments, you're still negating everything that I say. My company is complaining everything we blew up. I blew up a GPS. And that's not that big of a deal, right? A bother. You worked in GPS devices for the whole second part of your professional career. Well, that was the middle part of my profession. Well, no, that's not to say I didn't just blow up a GPS. I blew up a DIY terrorist GPS. It had an LCD module on it, and it had a bunch of different menus and functions. It was a very advanced, very cool device. Very interesting device. Back in the days when GPS was sort of at a fledgling state, especially over there. So this was a very interesting device. I got photos of every single menu and menu item, luckily. And then I found a transistor that I wanted to test because it appeared as though that transistor was turning on a backlight, even though none of the menu functions allowed you to turn on a backlight. So I said, you know what, there's probably like a menu function here, and I can probably enable a backlight with it, and I want to be able to write about that. This is way late into writing the whole report on it. And so I touched a jumper to that pin, and it went blank. So yeah, some people do care when you mess something up and it explodes. It didn't really explode, it just stopped working. Do you know how to program the Arduino Nikla voice? I don't even know what that is. See if I know what you're talking about. Easy implementation of always-on speech recognition. That is a very advanced little doohickey right there. I've never heard of this thing before in my life, but it appears as though there is plenty of information about how to program it out there. It even has weird disembodied hands in the video. Whoa. Oh my God, that man said something. beep, boop, beep, and then it does stuff. Well, that looks cool, but I don't know anything about it. Okay, so we're going to run the test program on this. We're going to get a little sample of display. There's no reason why this shouldn't work. Let's watch it explode once I program the micro with the new code. And then we'll move the audio stuff in with the screen code, and we'll see whether or not, you know, it can handle the stress. We're going to ramp up the stress on this thing piece by piece, right? One thing at a time. So power that up. We go to the programming window, which is here, and this is our bussy test. So the port Teensy 4 serial 600 megahertz. That is so many megahertz. 1.08 gigahertz overclocking it. I remember when I got a 1 gigahertz processor. I think it was a Celeron. COM5 serial Teensy. So let's go ahead and upload this simple test program. I did a little rewriting just to make it a bit cleaner. Wish I had friends like you. You know. You become that friend. Oh my God, what happened? Using library and folders, sensors, blah, 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 GU7000 legacy. Candidates, delay basic. Oh, it doesn't, maybe it doesn't like the delay? Fatal error, util delay basic. Okay. Just that. Just correct our delay. What's that? What happened? Sub for 6 months. 4th time on board. The board is not active. I haven't said anything about the board in a long time. But thank you for the sub. We'll figure out how we're gonna get names on the board. I don't know how that's gonna work. I was once on the board. I know. Looks like a cheap CIA intro. I guess so. Again? What happened? Documents, Arduino libraries, serial async, fatal error, util delay basic.h, no such file or directory. Oh, it's probably being called up here. What in the world? Why is this? Don't know how to program, but it's super entertaining. I'm glad, because right now it's going to be kind of annoying. So I got rid of the delay that they wanted, but apparently somewhere in their code there is a delay that is not appropriate. Yeah. Util delay basic in documents Arduino libraries. Why are they using delay basic? This would be, I think this is the Stoffrigan library, unfortunately. C users bother, that's downloads, that's not the right one. Close that. So, documents Arduino libraries, GU7000. And then this is running into it in serial async .h util delay basic.h. So what can I do to solve this? Let's Google it. Using Arduino, blah, 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 blah. Same error. Okay. Why do you need software serial? Oh, Jesus Christ, shut up. Thank you for any try. Suggest abandon this thread and go back to the other one. God, I hate forums so hard. As you can see, check my other post. I solved it. Can you guys please just give me the answer? God, and that was the top result. Trying to learn C++, any tips? If you're trying to do it for, well, I don't know about C++ for embedded. I took a class on C++. I don't know if that would be beneficial. I don't know, because I don't really know. I know of C++. I don't know how to start off in it. You could probably find a project that you want to do and just progress from there. In terms of getting the basics, I'm sure everyone and their dog on the internet wants to do a tutorial about how to code C++. So you need to find one that you can process properly and one that you can sit down and follow along and listen to, and do not hesitate on doing the basics of the basics. Don't get caught saying, I already know how to do this. This is too simplistic. You want to do those simple things because that's what sort of builds up towards the complexity. Yeah, they're so mean when they see something that's already been solved. It's like, but yet we're coming in here for the perspective of doing a Google search on the problem, and we found that this person asking the question had the closest thing we have to the problem, but then everybody comes in and they're just awful to the person asking the question. And so you end up getting stuff with a thread where they're not comfortable sharing their answer with anybody. And so we end up not getting any sort of an answer to our problem. It's just hideous. So I'm working on IoT Cloud Data Logger, so this is a very similar thing. Util delay basic.h. So here we go. That's our error. Home builder opt libraries latest. This does not sound like a typical directory. Jesus Christ. Familiar with these paths. Why use software serial? I can switch it over. Why do you use software serial? Oh, God. This could be due to a non-standard location of the library in the weird way that the Arduino IDE looks for code. Library paths on Arduino create are documented. So the 4,500 libraries in the Arduino Library Manager are installed under that folder. Home builder opt libraries latest. Visual Software Library is platform bundled library, which is not bundled with the Arduino. Samson. God, we're getting into some weird stuff. Dabble contains a filter named software serial H. Library discovered finds a random library. What the hell? That doesn't explain it at all. The official software serial library is a platform bundled library, which is not bundled with the thing, the new platform. We would normally expect it compiling this code for the MKR GSM 1400 to fail with an error like blah. However, there happens to be a library named Dabble in the library manager, which contains a file named softwareserial.h. So the library discovery process finds this random library, and you get a confusing error message. Is that what's happening? Are we finding a random library? Oh, that's a frustrating one. Yeah, there's a book suggestion for, which one is that? Bruce Eccles. I've heard that name before. I don't know why. My window, for some reason, is really, really wide. This is very frustrating. I'm pretty frustrated right now. Reddit can sometimes filter some stuff out. I need to drag Reddit over to the side a little bit because it, first of all, they don't load old Reddit. Second of all, new Reddit wants me to log in with my email addresses that are associated with my Google accounts, which is not what I need doxed right now. I see delay basic.h in your screenshot. Should it be include delay basic instead? I created one from raw code I sent on Git. What the fuck? Dabble. There's that Dabble again. Is this the same person just asking their question somewhere else? 2 years ago, but I deleted. The delay basic file is a standard part of the standard ADRC runtime library. It should be available as soon as you have successfully installed the IDE. You might want to uninstall and reinstall your IDE. I'm not doing that. Few releases behind the latest release, blah, blah, blah. When installing IDE under Windows. Okay, we're going down. Thanks for your reply. The delay basic and the interrupt.h, we were giving me the blues. I want older version. Hopefully, nope. Not related to Dabble in any way. I do not have Dabble support library installed. Stop saying Dabble! These two files exist for me under the hardware folder of the Arduino IED itself. Include util delay basic.h. I'm not doing dabs. I really wish Willow would come and hang out again. She doesn't come downstairs when I'm streaming because I'm sitting here like yelling at the wall. I'm just sitting here yelling at the wall and like pontificating at it, and that's not good for a sleeping environment. So she's upstairs at the front door where she can bark at the mailman or anybody delivering a package. Unfortunately, that means that we don't get corgi time down here. I would love to have her come visit, and I could, oh, look, there's corgi. Look at the corgi. And then we would all be like, "Aw!" But unfortunately, the only place that you guys can get your fix of Willow is in my Discord, where we have a pets section for pictures of animals you've taken. So if you go to the zoo and you take a picture of a gorilla, post it up there. That's great. But if you find a picture of a cat on the internet, don't post it up to that channel. Okay, what's the solution, Reddit? I created a blank sketch just as you mentioned and added the include directive at the top. So include util delay basic.h. So did I miss that in the example? I might have. The book was last updated around 2000. Yeah, but C++ doesn't evolve that much. The basics of it anyway. More than 20 years ago. I didn't learn C in the year 2000, but I could have. I took a class in C in the year 2003, 4. It was a college class. Still sounds like something wrong with your default IDE installation for its dependent folders. Something else may still not be correct. I don't know, because my folders have been through a lot, but they still work. Restart the compiler. No, I don't think it's a compiler restart. They said reinstall, so. But I might be missing an include at the top of the, let's look at the example again. File, examples. And we're looking at the example of, why does that keep, like, that was weird. GUI 7000. And this was the large text demo. We gotta wait. It takes a while to open. That's the other thing. It evolves that much, but it does not involve that much, are you saying? Or it does evolve? It evolves that much, but specifically in embedded environments, you have new C++ language features. That's true. If you're trying to do embedded, yeah. But I mean, the basic concepts, right? The way of thinking of putting things together. I don't know. Yeah, maybe start with a newer book. It's not up here. Strange. Strange. Well, let's put it in anyway. Let's see if that does it. And we wait. Damn it. So GU7000 serial async.h. Fatal error, util delay basic, no such file or directory. So that's this. Util delay basic. I guess that gives it different delay loops, huh? Well, shit. Updated by Cody Johnson of Noritake Co. Incorporated. Huh. 6/24/2015. VFD, GU7000, RX delay cluttering, blah, 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 ASIC public, util delay basic. So in this library, GU7000, There's no util there. And I guess it's looking for it in Arduino, but it should exist. Ah, it's not in Teensy, it's specific to AVR libc. Well, how the hell do I get it to work here? This is a weird problem. I wonder if there's an updated version of this library or something that I should be using. We don't need any of these anymore. Back to our search. So we tried that. That didn't work. I can't stand the new interface. I really hate it. There we go. Trying to flash diagnostics INO sketch from the SPI memory library 3.40 and an Arduino Nano 33. And they get the exact error that we're getting. This seems to be a more common thing. Did you verify that the util folder C users owner documents Arduino library? Let's check real quick. Even though it's the only comment. Try including for non-AVR boards, include Arduino.h. Really? Is that going to fix it? Arduino.h. I've seen this done in some of the non-sequitur boards, but nope. Same thing. Candidates, fatal error, util delay basic. No such file or directory. Son of the bitch. It's implicitly always included. All right, well, yeah, I'm just trying stuff. All right, C users owner documents Arduino libraries. That should be fine. All right, let's see if anybody has actually solved this problem. Compiling. Let's go to old Reddit. Need a plugin that just swaps me over. They're getting it by just trying to include util delay. Some libraries don't work on very well don't work very well on non-AVRs. Yeah. I guess I can try to use the Paul Stoffrigan library then. That's funny. What were we using before? I think we were using an Arduino platform. We were not using Teensy when we did all the screen stuff. Maybe that's why that library was working perfectly fine. That sucks because this looks like a pretty easy library to use. No answer. Just wonderful. Wonderful amounts of support. You're missing util delay basic.h, but the other messages warning, blah, blah, blah. Yeah, it's weird that I tried like including it and doing all kinds of other stuff. Let's use the other library then. But the other library was so specific. Maybe we find an update to this one. GU 7000 series library. Is this not the one? This is not the one that we got from. Wait, this is the one that we got from the library manager. I could try starting up Arduino again. Let's just try. Let's close this up. ARD. Start that up. Packages, boards. Starting. Starting. There we go. Okay. New version of Arduino is available. I mean, while yes, I should update. Nah. It's a large text demo. GUI 8 7000.h. My code here. Try to get this thing up and compiling and just see if a restart did anything. Yeah, it's a graphic and character display VFD, and it is like $100. I got this one off of eBay with one other one. Any wonder they were listing it on eBay, probably because it was so frustrating to get the thing to work. I wonder what else, what other issues I could run into if we just solve the one problem in front of my face. File included from C, blah, blah, blah. Update my libraries. Possibly update my boards. Yeah, I haven't done a board or library update, so maybe that'll help. I don't know. We keep getting this stupid error message. The fact that this is a graphic VFD means that I'll be able to display waveforms and stuff. So it'll be nice. Oh, my butt. Been sitting in the same position for too long. By all means, this thing should work just fine. It's just that they decided to use some possibly AVR specific things, like the special multiple delay library. Yeah, the include file delays, or the include file errors are very annoying. If I were you, Bother, I would just make it work. I would just solve the problem. Why don't you just solve the problem? You're not solving the problem. Okay, update all. I think we got that done. Oh, I see. I need to update all of these things. All right, let's get through it. apt-get update. apt-get upgrade. How's it going, Pyro? No, wait. Install. I want update, not install. Viewfire, let's see. TMC stepper, SPI, RF24, matrix display, one wire, maybe, yeah, that one might need. LVGL. Oh, that's right, the LVGL library. That's for like color graphics libraries. HX711, no. Fast LED, no. Dallas temperature, no. These are things that I love using. Oh, there's an update to Bounce. Bounce 2 is a very good library. WebSockets we don't need today. JSON, no. Arduino timer. There's a lot of updates. Circuit Playground, Servo. Are the libraries we're using in here? No, they're not. Okay. Yeah, that's annoying. So we have the latest of the library. It's just that the library does not like our microcontroller. Actually, wait, let's add Teensy to that equation, because there's a chance that this has been addressed. Teensy 4.0, what was it called again? I forget what the search was. Delay basic error Teensy. Since today I get the error util delay h no such file at line blah. When compiling a sketch that worked good until now. Same error, and then Paul jumps in and says, I tried it now on Mac OS, seems to work fine. Huh. Check which board you have selected in the Tools board menu. The wrong board selected is the only reason I can imagine this wouldn't work. Well, now hold on a minute. Wait, are my other windows still open? Oh, I didn't fully close Arduino. Whoops daisy. What a board do I have selected? Ah! What is that window up? Close this. So there's our waveform creator. Here's this one. Error compiling tools. Board's Teensy 4. So there's no faffing about with that one. Serial's fine. So it's something else. Let's see if they keep going on. I've selected board Teensy 3 and serial port to reproduce Load SD 1306, load the examples, try to compile and load. Teensy is not listed in the supported platform for that library, so I googled the missing file under util delay basic H, and it's part of AVR libc. The library you're looking AVR library C, but I call it AVR libc. Good morning from New Zealand. How's it going, Tequin? Tequin? I love the international crowd here. We got so many people from all over the place. The only problem is the only Aussie that ever watches my show is my cousin, and he'll come in with some weird screen name and start talking to me all familiar, and I'll be like, cool, I love the engagement. And then he'll say something about, like, my dad, and I'll be like, wait a second. Oh, it's you. Because, I don't know, he keeps losing account passwords or something. Or getting kicked out for being a shit-posting Aussie. Okay, Teensy's not listed in the support. Library you're trying to use is available with AVR and ESP32, but not with Teensy. Not every Arduino compatible. Yes, we've already been over this. We've already had people give me that smug treatment of telling me this. But now we're learning it for the first time. Not every Arduino compatible library is usable with Teensy. The developer or user has to make it compatible. There are other SD 1306. Yeah, well, that's not our application. First of all, thank you for your time. Second of all, fuck you. I am not sure about what you've stated. This makes sense. It's like all of the little like background library things that people use to make their library. Like, oh, I need multiple timers that are triggerable and have loops, so I'll use the our AVR library libc. They're not necessarily going to be compatible with any other microcontroller because some other architecture won't have the features that that library is trying to use, or it will have equivalent features, but they didn't necessarily think about connecting it. Because when you make a library for something, do you have a logic level translation between the microcontroller and display? No. The maximum voltage that the Teensy 4.0, I've already gone over this. I did this already. We looked at the maximum voltage input for the screen, and that's 3.8 volts. Well, no, the maximum output is 3.8 volts for the logic level stuff. And I've looked it up. The Teensy 4.0 can handle up to 3.8 volts. It's unfortunately not 5-volt compatible like the Teensy 3 and the 3.2. The main problem appears to be lack of checking AVR platform before enabling a lot of very AVR-specific code in the default case where a platform doesn't many. And what the point is, when you develop a library, you don't necessarily develop it for architecture other than the big popular thing that you're developing it for. So. Let me cook, please. So maybe if we use Paul Stoffrigan's library, this thing will work. Padawan of totally wait, why didn't my thing update? My social stream blade keeps not updating. Man, just let me cook. Yeah, it's weird. It's not updating properly. Okay, anyway, let's get back into this. So I'm not gonna solve the wait, what the fuck? Why is it showing me somebody's death? Okay, so what we need to do is we need a Teensy specific library in order to run the screen. We've run these screens before, but they were from an AVR microcontroller. So this is not AVR, so it doesn't have these weird features that the library might rely on. So what I'll do is I will get the Paul Stoffrigan library, and I think it's going to be a slightly more clunky install. Thanks, Zach. VFD from Teensy. Yeah, it's Ben Gizmo linked it to me when he was trying to remote pilot me earlier. What did I do with it? It's at the top of the code. So GitHub, Paul Stoffrigan, GE7000. It's not the software from Noritake. This is his own thing. And there's examples included in it, so maybe we'll be able to get it. This is the old, where's the download button, GitHub. There's the conversation about it. You must agree to this condition. Okay. How can I load this in? Can I actually add this as a source for libraries? Okay, that's up to date. Good, that works now. Oh, did I miss anything over here? No. Okay, good. I'm up to date with all my chats. All right. Code issues, pull requests, actions, project security, insights. GitHub is a bit of an annoying thing here. Yeah, I think it does that. And then clone, download zip, or GitHub desktop. Yeah, I guess we want to download the zip. Folder. So this looks oddly familiar. I think maybe this library just needed an update, because this is what we were already using. Yeah, this is what we were using. But let's just copy it over again. Maybe there's been an update to the library. This was updated in 2018. Let's see what we're using, because we already have that directory open. Well, these were copied in last year. But wait, why would we get the error if... it's Paul Stoffrigan's library, damn it. I guess I'll pull all the files over again. And restart Arduino and just see if it does that. But like, this is the Teensy library that we're using. Why wouldn't it work? All right, start up Arduino again. ARD, Arduino. Pull that up and let's try this. Let's see if we still get this error. It's like, bro, this is your example. Why is this failing? I wonder if it works on a Teensy 3 but not a Teensy 4 for some godforsaken reason. Teensy 4.1 stress. Okay, there's our stress test. So let's just try to compile this. The board is a Teensy 4. Compile. Whether or not I can use the Teensy 2, I don't have a Teensy 2 to use. Also, we need the super duper Teensy for its amazing mega speed. I could test to see if it compiles in a... Let's try, hold on, board, Teensy 3. Well, wait, could updating my board manager get it to work? Let's just see if it compiles for a Teensy 3. Oh, don't upload it. No. Unplug this. Why don't we go ahead and update my boards? Error compiling for the Teensy 3.1. Whoa. Raspberry Pi Pico, ESP8266, Mega AVR, and Arduino AVR. So none of those are Teensy. No, Teensy's don't have any updates. Well, Teensy installs as its own thing. Why is this not... Wait a minute. You're getting an error or just not running after loaded to Teensy? No, we're getting an error, and the error says that... Well, this is a different one. Fatal error, GU7000 interface.h. No such file or directory. Huh? I did a full copy and paste of the files. It's all in there. There they are. Interface.h, it's right there. Let's take another look at this. So board, I'm going to put the board back to Teensy 4. And double check. Yeah, it's in the library code. which is why we were talking about how, you know, you don't necessarily make your library support everything, but Paul Stoffrigan made the Teensy 4.0. So using his library, one would assume that he was coding it specifically for his microcontroller that he's famous for. So I don't know why we're getting this error. And it's from the library. It's from the GU7000 interface.h, no file or directory. I think maybe I need to start restart Arduino again. Why did it seem to not think that I had code in there? Interface.h is right here. Why is there some folder open with step files? What's going on there? This computer has been on for too long. So this PC local disk C users by this downloads. That one's the empty one. And then over here, I have this PC document Arduino library GU7000. These are all the same files. They just have a slightly different date on them. Is it spelled the same? The only way I'm going to get that back is if I Control Z. Interface.h from 2023. Yeah, interface.h. They're spelled the same. It's like, I feel like I'm taking crazy pills. It's just this one has a big README at the bottom. Second humble attempt to fix this library for non-AVR chips. This library is even an attempt to fix this library for non-AVR chips. So all the stuff we said earlier about non-AVR chips, out the window. This library specifically tries to address the issue. That's the wrong window. You guys can see how chaotic following chat is. When I look over at that other window, it's so that I can see this information. Ah, that's the wrong thing. The forum thread was for the Teensy 3.2. I tried to compile it for the Teensy 3.2 and it said it couldn't find the file. Yeah, is it only for the Teensy 3.2? But code for the Teensy 3.2 should be compatible with the 4.1 unless they're using some really like low-level weird stuff. Because the Teensy 4.0 is a bit of an architecture departure from the 3.2. Things like crimes and ornamentation weren't able to run on it. So that's funny. I think maybe it's getting closer to being a Teensy 4.0 problem for non-AVR chips. Methods.txt? No, that's not it. Huh. So, I mean, this is why we breadboard, because we find stuff like this, weird crap like this, that's unanswerable. Let's go back to this. I was looking it up last night, and you were looking up this exact problem last night? There's a ton of talk trying to get PWM to work on Teensy for some audio output. Yeah, using DMA. Yeah, the crimes and ornamentation thing. Or ornamentation and crimes. Julian seems to love correcting me on that, and I like just saying the wrong thing. They're getting close to, or they have already fixed it, that stuff. I guess it was because there was so much serial stuff going on the board, it would affect like PWM or something like that. They were using a lot of those like weird tricks where you're like, ooh, this processor can do something very specific. Oh wait, we didn't highlight the mod. No, this is the wrong. This is the one we're doing. File, open recent, and we're doing the module test module. Oh no, that's the wrong one. It was module Teensy 4.0 stress test. Teensy 4 stress test. So I got rid of the delay that was written in the style of that other delay, the underscore delay MS, but that didn't solve our problem. Somewhere in here, we expect to be loading the utils, like the Noratake 1000 whatever. Error downloading Digistump. That's fine. Go away. I need to like redo my compiler. But let's try compiling it again. I undid the cut and paste of the folder. Going to have a nyap. Everything is nya this and nya that. All right. So this is a different order error, I think. Candidates GU 7000. Resolve library util delay basic. Huh? Hold on, let's make that a little larger. Look, some of it is fixed PWM, strange timing and multiple DMA access, some odd behavior where certain pairs of pins caused issues. I was trying to do pre-research on making my electronic music instrument. Oh, that's cool. Yeah, that's a pretty pretty specific issue, the whole Teensy thing with the switch to Teensy 4.0 because of supply issues. Program files, Arduino, Teensy tools, bin, ARM, blah, blah, blah. Wall function data. What the? Ah! What does that even mean? Darduino lib discovery phase. What? Alternatives for util delay basic.h. Nothing. Resolve library, util delay basic h. Bother desktop. Teensy blah 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 blah. Stress test. Candidates. So it's just like searching for random stuff now. See user documents, Arduino libraries, GU7000, serial async, fatal error, util delay basic.h, no such file or directory. Compilation terminated. Using GU7000 in folder, documents, libraries, GU7000 legacy, error compiling board for Teensy 4.0. This library was an attempt to fix this for Teensy's. So if we use a Teensy 3.2, and try to compile it, what happened? The exact same thing. It doesn't find delay basic, and it searches for it. So this is currently a problem. So what if I do another Teensy? The Teensy 2, I don't know, Teensy++ 2.0. Not upload, I keep hitting upload. Well, it's going to compile before uploading anyway, and presumably run into the problem where it doesn't have that. Whoa, whoa, we're still going. Yeah, no Teensy boards were found plugged in. So this one completed. TX-RX delay, parallel uni, file included from C users by the desktop, U7000, parallel.h, constructing parallel. What the hell? This is a totally different error. Warning, unsigned character 4 for the busy pin. Well, yeah, these are some weird warnings. I guess this is the verbose output, but it did compile. It ended up compiling everything. So Teensy 2 has the utility, the ability, and all these warnings are just like, you know, the simple warnings for compiling. Serial async delay centering. RX delay centering. It doesn't like the underscore ahead of something? Parallel UN8T. So it's giving me like crazy compiler warnings, but it's not saying anything about util for util delay. Okay, so what can I grab from the Teensy++ 2.0 under the boards library that'll fix this? Oh, Teensy 2 is at Mega32U4. I didn't know that. I see. Huh. Regular old 3.0 will probably run into that error. Let's try it. You know, all I've been able to get done today is hooking up the screen and looking up a bunch of voltage levels. It does not. No, we tried that. I'll do it again just to display. Is that the correct slash? Yeah. Why is it highlighting like that? Include util delay.h. Should not be highlighting delay in that. Oh well. Delay.h, let's just check. Oh, I don't have the right board selected. Well, we'll still get the same error. Presumably. I can't believe this library is my attempt to fix exactly the problem you're having. Broken. I don't think I can just bring the library over. I don't know if that's exactly kosher here, because it might be using timing stuff that's not implementable in the other architecture. I don't know what commentary there is about that. Teensy 4, all that stuff's configured properly. We've got the same. Well, let's check to see what the error is with the Teensy 4. What if I put it in quotes? Dead. Okay. What does putting in quotes do? Now the error says delay basic. Oh yeah, you're right. So it turns into delay basic. That's when it looks in the current folder. Okay. Well, if I include it in desktop, I guess I could do that. But I don't want to necessarily move delay H. Let's see if we can find anything specific to the Teensy 4 on the internet. Where is my Bower window? There it is. So browser right there, and let's look up, because like, are there any issues? No. Is anybody talking about it? Talking? So you're watching it. No forks. What a thankless job this man has done. Unfortunately, it didn't pay off for us. Comment out the include file that gives an error. The include is using delay basic. We looked at the files itself. Like we looked at the serial async. This is where it's using util delay basic, and what it's doing is it's using RX delay. Hold on, where is that? RX delay, TX delay. It's got these like loop timers and stuff that it's actually using in the code. So like delay loop 2 delay. It's using this pretty extensively to do its stuff. And this is for the asynchronous serial, so we need this. We're doing asynchronous serial, so we need this. What a bunch of piss. This is so annoying. So can I use delay basic with Teensy 4? Let's do Teensy 4 delay basic. Google the delay basic, Teensy 4 audio effect delay, encoder.h library from PJRC, not compiling for Teensy 4. That would have been another thing that we ran into. So everybody was telling me, oh, Paul also has a encoder library, although this could be old. This could be from, yeah, this is from 2020. So check this async file. He has an if-def AVR. Is that, so wait, let me look at the one that I downloaded and see if that's in there. So this is the one in downloads. That's interface. Hold on. Serial async. Oh, look at that. This one's been updated. This is new. Aha. So the code has been updated since I downloaded it last year. So let's grab this and put it in there. So that should have worked. Onboarding. Why are you guys all getting on a board? What a waste of your time. I just deleted the download one. Hold on. Control Z. Copy this and replace the one in the libraries. And I'll make sure to replace everything. Been here a year and they forgot about me. So now I have to do it. That's kind of what it was like when I started the classified job, because you had to sit there and just like you had to do pseudo work. You had to do research about the job that you're going to be doing until they can get you a clearance. Boy, work from home would have been great then. I was doing all kinds of stuff at that point. Like I was just like getting totally distracted by like programming projects and stuff like that. So if I just carte blanche, like if I just do this, will it pull it back in? I wonder. Duh! You bastard. Well, this is different. GU7000 interface.h. No such file or directory? What? Huh? Why would it be trying to find this on my desktop? Why would it not be finding this in the libraries? What's that all about? That's so weird. What is going on? If it's like not in my sketchbook, is that a problem? I guess maybe that might be the problem. It needs to be in the sketchbook. That doesn't make any sense because we've been using other directories for a long time. Or is AVR is just getting confused because I overwrote those files. Let's just like close it down and open it up again and see if that does it. I thought I'd get away with opening files like that, because I really shouldn't call upon them until, and it might be that it's not in the sketchbook, which is a little weird to me because we use those, like we use my file server directories and everything is usually perfectly fine with it. Hey, Caravos, how's it going? So we need the stress test. I hate that they have this like sketchbook thing. It's like I have so many projects that please test with examples for the library distribution rather than the example you took from Noritake. Why do you think I did that? I'm using the thing from the library. That's what this is. I wonder if the examples changed at all. That might be a thing. Oh, don't keep that in editor. Yeah, that's fine. Okay, so let's double check the example on GitHub and see if that's changed at all. On GitHub, examples, and then we have large text demo. Interface, parallel, serial async, serial SPI, serial sync, Noritake VFD GE7000. And then calling on that, asynchronous baud, all that stuff. baud sin bussy rst, baud sin bussy rst, parallel only. That's not what we're doing. Setup. All of the code interface is the same. Is generation B. I think one of the big changes is using a different generation, and he also commented out this line. But VFD begin, the size of the thing, enter 4-digit model class number, e.g. 7040. Yeah, okay, we got that. Interface, 1, 1, false, 1 by 1. I think that's the same. Yeah. Set font size, set font size, set font size. 1, 1 false, 2, 2 false, 3, 2 false, all invoked the same way. VFD dot. And then the delay, in this case, he's got this type of delay. I took that out. It doesn't matter. So our code is still compatible. So with all that stuff, close this. Try to compile now that we've restarted. No, it doesn't hurt to double check, but GU7000 interface.h, no file or directory. Why is it that it thinks that? Why does it need to be in the sketchbook like that? I've used libraries before where I didn't have to be in the sketchbook. I was in my directories, and it didn't. It's very strange to me. None. I guess maybe it doesn't find it, and then it jumps into the directory to try to find it. Alternatives for, yeah, so program file hardware, Teensy tools, arm bin, function set, class F data. No, that succeeded, though. Library discovery file. And then it looks for alternatives, even though I copied all the files into that directory, and it seems to just hate it. Where'd you put the library files? They're just in the library folder. I put these where the other ones were, exactly. And they all have the same names. It's the same text. There's just slightly different code inside of some of them. This would be akin to me going in and editing them just a little bit, like change a number here and there. It's searching for these locally, so that should be going into Arduino and then libraries. I don't know why it's not doing that. And then here we've just got the GU7000, and there's the files. The linkage isn't to like a memory location, it's a link to like the text of the file, isn't it? So weird. These are such weird problems we're having today. Using core Teensy4 from platform, and then program files blah. That's all the setup. And then it needs alternatives for the G something or other interface. I don't understand. Let's just open up an example and run it. And this would be the GU7000. Character sets. It takes a minute to open these things. Okay, so there's this. And it's got all the same calls, but this is from the example folder. So if I go to compile that, new errors. volatile uint32, aka volatile long unsigned int, to volatile uint8t. Why is this so broken? Is it because my interface is old or something? sreg was not declared in this scope. Wow, this is fraught with issue, isn't it? Using library GU7000 folder user, oh bother documents, blah blah blah, libraries GU7000 legacy. Interface was not declared in this scope. Well, what's the parentheses legacy doing on that? Maybe that's the problem. Maybe I need to reinstall this whole thing. Aren't the file names GE, not GU? Oh yeah, that's what it is. You're correct. You're correct. But the GE and the GU, I guess maybe I need to install the GE library, because that one might be the one that is updated. I didn't even notice that. Because, I mean, the GE and the GU have the same interface, but the GU7000 library was not updated to work, I guess, with so this is GE7000. Is there a GU that has had updates? Probably not. Although if it's the same thing, I might as well just go with the other one. What up, first time chatter? Oh, we'll never find it. So, okay, so GE7000. So we're just going to install this as its own library now. I guess the parentheses legacy. I guess this screen is a little bit old. Not that I care. It's a $120 screen. I'm not going to go buy a new one just to be up with the times. So anyway, if we can get it to work under a library that's not exactly the right thing, that'll be fine. So GE7000 master, I'm going to grab this. Well, actually, no, I don't need to do anything with this. Never mind. I don't know, I'll hit copy on it just to undo the cut. No, what I do is I go into the library manager and we find the zip file in the downloads folder. So tools, I forgot about that process. If I had reminded myself about how Arduino works, I could have saved myself a little bit of time. Include libraries, manage libraries. Or no, it was the I selected the wrong thing. And now it's going to take forever to pull it up. Oh my god, the library manager takes so much time. Okay, there we go. I tried to use the new version of the interface and it was terrible. And I know there's other tools to program Arduinos, but I do want to show the common ones. Like, I downloaded it and tried to install it, and it just didn't start, and it broke everything. So maybe one day I'll just wipe this computer. This computer is supposed to be wipeable, much like a bottom. Because it gets full of shit. Like, I've got programming tools installed in here from like 5 years ago when we were trying to mess around with like three-phase motor controllers and stuff. Like, things that just don't work are still gumming up this computer. So this would be sketch, include library, add zip library. And we want downloads, so that's accessible from here. I don't want to rename my downloads folder Windows, you piece of crap. Wow, thank you for ordering them in a logical manner. Who the hell knows what? View, details, date modified. There it is, GE7000 master, boop. I think we're in for a computer wipe sooner rather than later. What is all this? Interface was not, oh, this is, wait, Java language, null pointer exception, runtime exception, caused by Java language null point. Oh my God, what the fuck is going on there? Does that mean I have the library? It's a, hey, guys, examples. GE7000, there it is, okay. Large text demo. I guess it means it's okay. It's just we did verbose outputs, so things tend to get a little squirrely. And then check to see if it compiles. And if it does, we need to change our U's into E's. And then our screen will work and will be popular finally. Son of a bitch. Okay, so now we have this style of error. Cannot convert volatile uint 32. Did this still compile, or did it cancel compilation? Using library GE 7000 master in folder C user, oh bother documents, Arduino libraries, GE 7000 master legacy. Interface was not declared in this scope. It does mean that it was canceled. Oh, select which interface to use. I see. So actually, our code, our test code will work, presumably. We didn't do this step. So let me close that. And instead of GU, we do GE. GEU? GE. And this one's GE. What am I hearing? Oh, it's a bird. Okay. I thought it was a dog squeaking. I think Willow's just asleep upstairs. She's fine. She had a nice morning. She got to see all of her buddies. We took a nice early walk, and it was so humid that it felt like we were in a goddamn greenhouse. It was all, you know, like when you go to the zoo and they've got like the bird area and it's 1,000 degrees in there and everything is squirting water. That's what it felt like this morning. The humidity dropped though. It should be a little bit more comfortable. I'm watching on 360p and can't read text on the screen. All right, so let's see if we can upload this code. I still have 4.0 selected, right? I think I do. So I think we've got everything sorted out here. We might run into a couple errors just because I have unsigned characters going into son of a bitch. Oh, GU 7000, GE. GE. And then GE. All my U's are E's. Because it's basically the same exact code. All right, anything else? Oh, well, these are my own variables, but I guess I'll change them to GE. No, we'll keep them GU. That's going to be confusing, but whatever. All these variables are mine, so those should be fine. What's up, Haystack? She gets some screen time when she's in the lab. She doesn't come down here anymore because it's just me shouting at the furniture, right? Like I've got the cutest. I have the cutest corgi puppy, right? She's the cutest. She is certified. I've got a certification. It's signed by Obama, and it means that I have the cutest corgi puppy in America. But the problem is she doesn't come downstairs. She stays upstairs because it's quiet up there, and she can sit by the window and bark at stuff. So unfortunately, the days where Willow would come down here and say hi are gone. She's decided that she likes to be upstairs where there isn't a weird guy shouting at the furniture. All right, this should compile. This I'm 100% confident. Yeah, in pet stuff, there's plenty of pictures of the corgi in the Discord. And by I'm 100% confident, I mean, please work. Oh, God damn it. So we're back to Sreg issues. Cannot convert volatile uint 32t, aka volatile long unsigned int, to volatile uint 8t, aka volatile unsigned character, in assignment transmit port register equals port out put register port. I don't know what it means. Initializing here. Okay, let's drag this up a little bit. So there's a lot of little errors, but in file includes from C users, oh bother desktop, Teensy 4 stress test, documents, Arduino library, GE 7000 master, blah, 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 blah. Parallel.h in constructor, GE 7000, parallel, uint, unsigned JRB2, pin 3, JRB jumper, 0, busy, reset, nothing. Huh. I don't know. This is going to take a little bit more figuring out. Maybe we need to get into this tomorrow because it's getting up there in time, and I have to pee, and the dog probably has to pee. So, file includes from CU the blah 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 blah. Oh bother documents, Arduino libraries, GE 7000 master, parallel.h. So we can look in parallel.h. Parallel.h. What's up, Bomberdackle? There's an element of fun to it. I would be mostly having more fun if my screen worked, because we have a large amount of stuff to get together to get this thing to function. We have a large amount of stuff. This needs to do many different things in order for it to become a modular, synthesizer testing module, a modular synthesizer testing module, and I have one of my fanciest screens running this whole thing. I should point with my crooked finger. Where's my crooked finger? There we go. I have one of my fancier... God, that looks super weird. Okay, I'm not going to do that. Like a year ago, 2 years ago, I fell down a flight of stairs and I broke my whole skeleton, but at the same time, I also bent my finger. And since this wasn't enough to like fix on its own, I just now have a bent finger. It's great. I love it. It gives me dysphoria. Anyway, the point is we have this very fancy screen, and it's a VFD, which means a vacuum fluorescent display, and it can actually, I can point around corners. So this can display like stuff and text all at once. There's actually very little screen area in this, which is kind of unfortunate, but I could make this print out like waveforms and stuff. It'd be a very cool asset to have running on a module testing module. So we have this Teensy 4.0, and the Teensy 4.0 kind of shakes things up. It's extremely fast, like extremely fast. It's, boy howdy, it's worth every penny. So there's a lot of really cool hardware here. The thing is, the person who made the Teensy 4.0 created a library, there's a hair right there, created a library specifically, a lot of S's in there, the de-esser had to do quite a bit of work just then, specifically to run this generation-ish of screen and display text and stuff on this microcontroller. So we found the library, we found that there was a bit of an update, we found that I was using the wrong version of the library, we found that there were modifications made in the library to find that it still didn't compile. And so we're dealing with that non-compilability. I thought this was a good time for me to just circle back and update everybody on what was going on. So like, why do you hate me, library? Why does this suddenly throw up all this stuff? Parallel.h in construction. GE 7000 parallel. I'm literally just going to take that part of the error message and punch that into Google and see if I can get some insight. I mean, I could just try to actually understand the error, but I don't want to edit the library. Teensy 4.0 error. What? This is a totally different question. I mean, no such file or directory. Troubleshooting common problems with the Teensy USB? No, that's not it. Recognized by loader. Teensy not recognized. This is a Teensy 3? That's a generic troubleshooting. No serial port, push button, LED blink, large programs mysteriously crash. Nope. Although we might have a large program at some point. That'll get there. Windows 7 unknown device. No. Okay. Missing file causing compilation error. That sounds familiar. Having trouble getting the Arduino ID to order the compiles of the USD packages. Teensy compile one of the bin file does not exist. I guess it's the file blah 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 blah. The file blah 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 Teensy compile 3.1 blah is not shown there, or the compiler would have found it. Check the path, update the path. Well, I got that file plus 30 more in the path. Check out the Teensy forums. This topic was closed. Fuck. I hate the internet. All right. So, parallel JRB will be initialized after. And it's telling me in the construct, parallel.h in constructor, GE 7000 parallel. 7,000 parallel. And these are a bunch of unsigned values. And there's JRB2. Pin 3, JRB jumper. It had some problem with JRB2. Wait, does it? Problem in constructor, and then it's got a bunch of problems. Well, that's a warning. So warning, JRB will initialize after JRB2. Of course, we don't even have a JRB jumper on this model. I don't know what that's all about. I guess it's set to nothing right now. 0 is busy. Should that be, that shouldn't be changed. We shouldn't need to change that. Default, I guess. Bless the forum poster, yeah. God, this is frustrating. We're getting kind of deep into it right now. We've had nothing but errors trying to compile these screen tests. Even though I've used these screens before, I think we used the Teensy 3, and we somehow got it all to work. I may need to just use a different library, one that's a little bit less easy to use. So down here, there's another error. I mean, it seems like it powers through the these warnings. And then we have C user documents, blah, 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 master warning. No, that's still a warning. Hold on. Centering, A0 baud rate, and then we get the red line. Arduino libraries, 7000 master, serial async. Cannot convert volatile uint32 to an unsigned character. I mean, it doesn't stop until it gets to the sreg. What is the sreg error? Sreg was not declared in the scope. uint old sreg is equal to sreg. The hell does that even... So it hates the port assignment. Virtual void? What the hell is a virtual void? Serial async H. Man, this is above my pay grade is what's going on. That's the GUX file again. Didn't you need GEX? Wait a minute, what? No, these are GE. GE. This is GE. What was up here? It didn't say GU up here, did it? GE. SREG is an AVR register? Yeah, you're right. I do have the GU open here. Let me open the proper file. So I need the GE. That's not confusing at all. Parallel with GE 7000. I'm originally from Nortaki. Same dealio though. Man, we were cooking there for a little while, right? We were doing stuff and things were happening, and we were able to check things. And I should have saved the input stuff for today because that went super swimmingly. I did this during my Wednesday. I should have done the screen stuff during my Wednesday, but instead I did the input stuff and got that all ready to go. This is the op amp that takes the input in, and I even blew up an op amp in the process. It would have been a much more accessible stream than this one. But unfortunately, we're stuck here in the dregs because our Noritake screen doesn't seem to want to play nice with Paul Stoffrigan's library. It's still having a lot of trouble. Let's see if we can get more information about the GE7000 library. Paul Stoffrigan GE7000. Let's see if there's a PJRC. Impossible constraint in ASM. Not quite the area I'm getting, but still. Got my first Teensy 3.2 board in 2015. Never mind. That's not going to help me at all. Spent a little time looking at this library. Its code is a terrible mess. Here's a copy where I fixed a couple things. Noritake VFD CUY. This is for a CUY, though. It seems like you put a lot of stuff into these CU libraries. Do we have like a... I'd have to search it. This 272 repositories. Oh my god. There's the OC Phaserville. Audio, Teensy loader, timer, shift PWM. There's just so much in here. Octo WS2812. There's his software serial. I wonder if putting something like that in there. Meeting canceled, pushed out 2 weeks. Nice. I don't know how much I'm going to be able to teach today. This is, there's another OC. So, searching. Is this... So this is BFD CUY. So it's not the right one. Oh, canceling a meeting 10 minutes before it starts. That sounds really frustrating. Because you get all your stuff together for that, and it's like, oh. So... There's GE7000. Update on May 24th, 2018. I wonder if this will compile for a different model of Teensy. Because if this is 2018, we would be like Teensy 3.2. And we'll check the GE one and see if it suddenly compiles. This is amazingly frustrating. I guess maybe I'm going to have to go back to a little bit more rudimentary of a thing. We're still going to use the Teensy 4.0, but doing the screen stuff is going to be very frustrating. Yeah, look at that. Works on the 3.2 because this library has not been updated for the 4.0. What does that mean? That's just crazy annoying. And it just has a bunch of warnings. And then this one is still airing out. The parallel one is still airing out. And we got all the warnings here. So, what 6 years ago for this update? I don't think, when was the Teensy 4? Please, AI, don't try to... Is that really true? February 5th? The Teensy board with soldered pins, July 18th, 24. So yeah, something from 6 years ago would not take the Teensy 4 into consideration. Wait, Teensy 4.0 dev, Spark Fun, June 18th, 2015. You suck, AI. You fucking suck. Did they say anything about the release date? What the hell is this? Oh, the memory layout. Damn. I don't know anything about these. Make it look at like when this was published, this web page. Look at it like on the Wayback Machine. August 7th, 2019, Teensy 4.0 release. Congrats on Teensy 4.0. I got my shipping confirmation from 2019. So yeah, 6 years ago was before. Article from 2019 on Hackaday. There you go. So yeah, our two sources have met. So now we know it's from 2019. What a great tool, Google. You just basically made an LLM model that is designed to lie to anybody that's searching for something on the internet. How fucking useful. I love it. I love the future. It's so great here. God damn. So mad. Here's a copy of what I fixed. Couple bugs. Terrible mess. That would be for CUI. This guy's trying to VFD display from Noritake in their library, which contains small ASM part. So what is the CUI series? CUI Noritake. Noritake. Ah, yes, the elegant casual dinnerware. What am I spelling wrong here? Nori take. I hate you, Google. I hate you so much now. Look at what you've become. Okay, so that's totally different from ours. That is not a graphical display. It does do bars, but it's English, French, Danish. Run! Multiple interfaces, font tables, descender. Oh, that's interesting. So what would the interface be? I don't know if it would be parallel. Parallel. Damn it, damn it, damn it. Not the French. Time to write your own. Welcome, welcome. There's not a hair left on this yak. The yak does not have hair anymore. We've gone so far as to use lasers to get rid of all the hair on the yak. But we still need to shave it. We're not done. I gotta start boiling the yak. That's what I gotta start doing. All right. Hi, folks. First off, this is from 2018. Apologies for resurrecting an old thread like this, but I'm dealing with a very similar issue. Cannot find info out there. Some of this thread is pertinent. I'm trying to get a Noritake GU7000 series VFD. This is my exact problem. 140 by 32. Watch. This is probably the person who I purchased the display from on eBay. To work with the Teensy 3.5, not having much success after the hour spent on it. Module without an mega. It's powered by 5 volts. It's connected async serial using 3 digital pins to the controller. Blah, blah, blah. Cannot get the display to do anything. The Noritake library, Arduino code library quick start, is almost identical to the one posted to this thread. It has the same ASM delay bit using the delay microseconds function. It does not make the error go away. Oh, this is the same crap that we're dealing with. Value doesn't change, garbage, blah, 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 blah. Almost always zone 15, the value 9200 baud. I thought perhaps signal level, but I checked the voltages of the pin, both high and low. First simple test, setting tools CPU speed only to 24 megahertz, so it runs at a speed different. Okay, so I'm not even getting code to compile. We're not even getting year. So, yeah, can't figure it out, sell it. So we're talking about code speed, but you guys are actually running code. View 7000, centering, blah, blah, blah. And this is on a different microcontroller, so it's a different hardware. Damn. I am the one person in the world that's trying to get this display to work. And I can probably do it using Noritaki's tools, their own stuff, instead of this library. This library probably would have cleaned up a couple things. But the question is, what do I need to do in order to get this screen running on the Teensy 4.0? So I'm going to take a break there because I think we've kind of hit a wall. I can continue to tootle around with this, but I think it's going to take a little bit more internet in order to get this to fully work. But that's why we're doing this. We're taking little tiny baby steps to get from a blank breadboard to a module that can sit in my modular synthesizer and test other modules. So we've got a brutally powerful microcontroller that doesn't quite do the stuff we want with my antiques. We have a really nice I2S audio output, and I've got new ones coming in the mail today, tomorrow. So we'll be able to do two of these to make 4 channels, and then we'll have all of the plugs will have an input that feeds back to an analog input. And so we're going to try to get all of that running. I tried to take the first step, getting this screen to actually put out data. If we can have it just display all of the inputs and outputs that it's doing, it would be fairly useful for sort of getting this thing like together hardware-wise and seeing whether or not the microcontroller can handle putting stuff up on the screen while also managing all the I/O. Unfortunately, the screen's becoming a little bit more of a problem, so I need to kind of pull it back a little bit, and maybe we'll need to do something without a library to make everything nice and easy to use. We'll use the Noritake basic Arduino library that's not going to use, hopefully not going to use, some of those more microcontroller-y, AVR-y kind of functions, and maybe that'll get it up and running. It's all the timing for a serial port is kind of tough to do in a microcontroller when you're not using the built-in serial port functions, and this Teensy 4.0 probably has different stuff. And there's I think ways we might be able to get around it. I need to do a little bit of reading in order to get there, unfortunately. So we'll do something tomorrow, maybe something easy. We'll hook up another one of those I2S interfaces and mess with that. And in the meantime, in the background, I can kind of try to search up stuff and see if anything will run. Now, the data's still broken on this thing. I mean, I could always edit COM right now. Yeah, let me edit the COM right now. I'm going to do that so it looks like I have the air of professionality about me. So we go over to the channel that none of you guys can see, and then I copy the last thing that Octaj said. Actually, we'll go way down to the bottom. There it is. And I need to take this. Hold on one sec. I got this. And then the next stream will start countdown to... I guess we can keep it as Toronto time. He did everything from like in Canadian. So that is not June 20th. It is, in fact, going to be July 26th. And now, if I go and do the end card, that's when I'll be on next. You got 20 hours to figure out this problem, chat. And then I'm holding you to task. Yeah, no, I don't know. This stuff happens. We'll get to the bottom of it. Tomorrow, we'll work on slightly different stuff if the parts come in the mail. And then, yeah, I'll see you guys on the Discord. In the meantime, Fallout London came out. I've got a debate about whether or not I want to actually do a huge install for that. But I guess I'll figure it out. I'm going to go walk the corgi. You guys have a good night. Thank you very much for joining me. Where's the button? There's the button.